warriors, welcome to JEE Flash 2.0. Before I start any further, do let me know in the chat box whether I am perfectly audible and visible to you guys. By the way, this is the very first session of mathematics with me and today is National Mathematics Day. Yes, today is Ramanujan's birthday, so what a great day to start with, isn't it? Okay, alright, I can see comments pouring in. I can see Divakar, I can see Deepika. Alright, I can see Death Stalker, what a name. Alright, I can see Ninja Ma'am, hashtag Ninja Ma'am in the comment section. Welcome, welcome everyone. Yes, welcome to the session. Good evening, welcome to the session. I can see MD Safin. Alright, Achiever, Satish, Abdul, perfectly audible and visible. So I've got the green signal from you guys. Let's just dive into today's session. Let's just get into the more details. So you've already seen the topics of today's session, which is limits, continuity and differentiability. Which belongs to which unit? This topic belongs to calculus, which is one of the high weightage unit in the mathematics. You all know that, right? And this chapter, if I talk about this chapter is a huge chapter, which will take hours and hours of mastery. But now, right now, I am here in front of you with this chapter so that you can get the maximum output from this session. This is the agenda of the session, right? Is the agenda of the session clear? That in these 3 hours, you will get the maximum benefit from this particular session. We'll cover all the concepts, as you can see. We'll cover all the concepts and most important questions which will help you in JEE Main 2024 January attempt, and most importantly we'll cover all tips and tricks in this particular session. Alright? Okay. I can see, will you make us to love calculus, ma'am? 100%, 1000%. I'll do that for you. Okay, but in return, actually I expect 3 things from you. If before I start any further, I expect 3 things for you. The very first thing is that share this session as much as possible so that we can get maximum interaction, maximum doubt solving, and that will eventually in turn benefit you only. Right? So share this session right away. This is number 1 thing. Number 2, you guys have to stay with me till the very end of this session, because towards the end we'll be covering continuity and differentiability, and by the end of this session actually we are going to cover those kind of problems which involve limits, continuity and differentiability, all 3 concepts together. And you all know the importance of the hybrid problems in which multi-concept are asked, isn't it? Yes. So stay with me till the very end so that you don't miss out on any important topic. And number 3, most importantly, I want your undivided, undistracted attention. So get your water bottles, get your notebook, get your pen and arch your back, and let's just begin with today's session. All pepped up, all charged. Yes? Alright. Okay, let's just start. So before starting the basic definition of limits, I have one very basic question to ask all of you. Just tell me the comparison between these 2 functions, or these 2, let's say, functions. Yes. So y is equals to x plus 2 and y is equals to x square minus 4 upon x minus 2. I have one very basic question to ask, that whether these 2 functions are identical or not. What do you think? Identical or not? By the way, what does identical mean? That means that the graphs of both the functions are same or not, are exactly same or not. I just want to know this. Graphs of first function, which is y is equals to x plus 2 and y is equals to x square minus 4 upon x minus 2. Are both the graphs same or different? Yes or not? Okay, I can see both are same. I can see yes, I can see no as well. Domain changes, no, identical. Okay, okay, okay. Yes and no, so I'm getting mixed answers. Let me just quickly tell you the answer without any further delay, that these two functions are not identical. These two are not identical. The common mistake which most of students do, what do they do? Okay, they see y is equals to x plus 2. Fine, ma'am. And what is this? X square minus 4 upon x minus 2. Let me just factorize this. This is what? X plus 2, x minus 2. I have applied that formula, a square minus b square, right? This is your 4. A square minus b square. So x plus 2 upon x minus 2. X minus 2 is already there. X minus 2 cancel. So this is coming out as x minus 2. The moment we get x plus 2, what do we say? We say, okay, x plus 2, identical, game over. No, but this is an incorrect approach. These two are not identical. Why? Okay, let me just ask you one more question, that I want to know that what happens at exactly x is equals to 2. Can you please tell me what happens at x is equal to 2? What happens at x is equals to 2? Let's just take the example of first. At x equal to 2, simply you are going to put y is equals to 2 plus 2. It will give you 4, right? At x equals to 2, you will get 4 in the first function. But what happens in the second function? So the question arises, where shall I put x is equals to 2? Here or here? This is the reduced form. We cannot put x equals to 2 over here. We have to put x equal to 2 in the original function. The moment I plug in x equal to 2 over here, you will get 2 square minus 4 by 2 minus 2, which eventually will give me 0 by 0. And which is not defined in mathematics, 0 by 0. So I am not getting, here I am putting x equal to 2, I am getting a 4. Here I am putting x equal to 2, I am not getting 4. How can these two functions be identical? So what's the status then? Let me just tell you. Let me just now reveal everything about these two functions. So y is equals to x plus 2. The graph of this function, how will the graph of this function look like? So y is equals to x plus 2. The y-intercept would be 2. And okay, so this is the graph of y is equals to x plus 2. And you can see the moment I put 2, I will get what? I will get 4. This is the 4, right? Here you will get 4 somewhere here. This is y is equals to x plus 2, correct? Now what about y is equals to x square minus 4 upon x minus 2? So if you simplify this, what will you get? Again, this is the correct thing. This is nothing wrong. Nothing wrong in this step. Nothing wrong in this step. But the moment you cancel these factor, this particular factor, you have to write specifically that you cannot put x is equals to 2. Everything is fine, rest, everything is fine, just you cannot put x equal to 2 over here, because the moment you put 2 minus 2, you will get 0 by 0. That's why, and you're cancelling, that means you're telling you can't put x equal to 2. So the graph of this function will look like, it will look exactly same as this graph, but the problem is at x is equals to 2. At x equal to 2, you will get a hollow circle like this. And it will pass through 2, yes. So this is also a straight line, but at 2 it is not defined. Can you see both are same except this particular point? At x equal to 2 you are getting 4, but here at x equal to 2 you are not getting 4. It's hollow. It's not defined. That means the question is saying that you can't put x equal to 2. Rest everything you can put, okay? So here comes the concept of limit. Here comes the need of limit. Why do we need to study the whole chapter limit? Are you getting my point? Here comes the question. So here comes the answer. If you can't put x equal to 2, I have one question, that can you put x equals to 2.000000001? Can you put this value in this particular function or in this particular function? Both the functions are same. Can you put x equals to 2.001? Are you getting my point? If I am telling you that don't put x equal to 2, then you will ask me, ma'am, okay, we are not putting x equal to 2, but can we put x equal to 2.000001? That means a value which is slightly greater than 2, or a value which is slightly less than 2. Can you put that? So the answer is yes. Definitely you can put the value which is slightly greater than 2, and we mark it x is equals to 2 plus, and this is x is equals to 2 minus. Okay. Rather, the more correct way of writing this would be x tending towards 2 plus and x tending towards 2 minus. X tending towards 2 plus and x tending towards 2 minus. Right. So basically what I am trying to say is there are three ways to approach. There are three ways to approach a function. Three ways to approach the value of a function, right? What are those three ways? So the very first way is x is equals to 2. The second way is x is equals to 2 plus, and the third way is x is equals to 2 minus. These are the three ways where you can approach the function. At x equal to 2, that means we are talking about, yes, let's say a is 2 over here. So this is 2 minus h and this is 2 plus h. So this is a is equals to 2. So this we have already done multiple times, right? This we are doing since ages. Since grade 9 we are doing this at x equal to 2. I don't need to tell you this particular thing. I need to tell you these two things, which is the slightly greater than 2, which we call it as right hand limit, and make it as arrow x tending towards, and this is x tending towards. So this is left hand limit. That means we are approaching, this is your left hand limit and this is right hand limit. So we are approaching the function from the left hand side and we are approaching the function from the right hand side. Okay, this is what we do. Okay, the way of writing, let me just mathematically write. How do we write things? So if I want to ask you that, okay, what is the value of function? Value of function where x is tending towards, let's say 2 minus. So this is nothing but value of function at 2 minus h. The value which is slightly less than 2, and we call it left hand limit at x is equals to 2. Right? The way of writing in mathematics. Okay? And if I ask you how to approach function from the right hand side, so you will say the value of function where x is tending towards 2 plus. This you can call it 2 plus h. This is your right hand limit at x equal to 2. And you already know that when I ask you the value of function at x equal to 2, you just simply write f of 2, right? And the limit, we don't care about what is the value of the function at x equal to 2 when I talk about the limit, right? When I talk about limit, I don't care what is the value at x equal to 2. Although I know the value, but I don't care what is that. I only care about what is the value at left hand, x tending to 2 minus and x tending to 2 plus. Okay? Okay. Let's just now formally discuss what is the limit. Okay? Formally let's discuss what is the proper definition of limit. Okay? So this is your graph. Alright. What if I ask you that this is a. So this is x equals to a. If I ask you what is the value of this function at x equal to a, will you be able to tell me? Will you be able to tell me what is the value of this function at x equal to a? Yes, in the chat box. Will you be able to tell me what is the value of the function at x equal to a? It's so obvious. This is L. The moment you put a, you will get L. Okay. Perfect. If I ask you what is the value of function when I am putting a value which is slightly greater than a, I can mark it as a plus h. See, a plus and a plus h. These two are one and same thing. is just the way of writing. So if I write f of a plus, I can say limit of function where x is approaching a plus, or I can say f of a plus h. All these three things are asking the same thing. The moment you put a value which is slightly greater than a, again you will get L only. The value slightly greater than L, yeah, correct, L plus H, to be very precise, L plus H, but we take approximate value. The limit, the meaning of limit is same only. The limit is the value function approaches, so it is approaching towards L. That's what I am saying. It is not L, but it is approaching towards L. I am also saying, but we will write L only. We won't write L plus H. Right? Okay. And if I ask you what is a minus h, so f of a minus, so this would be limit x tend to a minus f of x. What is this? If you approach the function from the left hand side, what would be the value of the function? So it would be the value which is slightly less than L. So this value is also approaching towards L. Right? Okay. Understood? Perfect. And I call it as what? Right hand limit, and this is left hand limit. And in this particular case, have you observed that your right hand limit is equal to left hand limit is equal to L, which is a finite quantity. That means, this is the definition of limit. This particular thing means your limit exists at x is equals to a and it is equal to L. Yes, perfect. When left hand limit is equal to right hand limit and is equal to some finite quantity, then only we can say that yes ma'am, limit exists at x equal to a and that limit is equal to L. I hope the concept of limit now is crystal clear in your head. Okay, alright. Now I have questions for you. Look at this graph and you guys have to tell me in the chat box that first of all, first question, limit exists or not? Yes or no? Limit exists or not? If no, then there is no point. But if yes, I need to know the value of limit. Value of limit. So what I am asking is limit of this function where x is tending towards a. What is the limit? This is the question. This is the final question. Limit of this function where x is tending towards a. What is the value? Okay, I can see Luxury Hitler is saying yes ma'am, exist. It is L1. Tanisha Kumar saying A, exist L1. Akshita, yes, yes. People are saying yes, but they are not writing what is the value. If you are saying yes, please write the value as well. No, yes. Yes and the value. If no, I don't need the value. So I can see Govithram is saying no ma'am, no ma'am. Arvintha saying no. Some people are saying yes, some people are saying no. So let me just reveal that limit exists, yes, and the value of limit is L1. This is the correct answer. Now let me just tell you. Let me just tell you what I am trying to say. So just give me answers of these questions. What is the value of f of a? What is the value of f of a plus h? What is the value of f of a minus h? Let us solve it together. So f of a, the moment you put f of a, this is hollow circle, that means the moment you put the value of x equal to a, you will get L2. Am I correct or not? Am I correct or not? The moment you plug in value a, you will get L2. Yes? Okay, alright. The moment I plug in a value which is slightly greater than a, that means I am talking about right hand limit, I can clearly see that this value is approaching towards L1 only. So can I write my right hand limit? So my right hand limit at x equal to a is nothing but L1. Yes. Okay. Right hand limit is sorted. Left hand limit a minus h. The moment I plug in a value which is slightly less than a, what do I get? I get approximately L1 only, right? So can I write L1? So my left hand limit is coming out as L1, my right hand limit is coming out as L1. I don't care what is the value of the function. I have already told you in the beginning. I don't care what is the value of the function. If right hand limit and left hand limit matches, limit exists, period. Okay? Cool? Alright. Perfect. What about this? Again, same question. Same question. Limit of fx, x tending towards a. Exist or does not exist? If yes, then let me know the value as well. Alright. Luxury is saying limit does not exist, does not exist, exist, does not exist. Okay. I guess everyone is saying does not exist because you can clearly see the moment you plug in the value which is slightly greater than a, you will get L2. That means RHL, you are getting L2, and LHL, you are getting L1. So clearly right hand limit and left hand limit are not equal. Does not exist. Perfect. That means you got the concept. I am super duper happy that you got the concept. Every one of you. Okay. Now there are few things which I would like to tell you, that what happens in this is a polynomial function, right? This is a linear function. This is a quadratic function, isn't it? So just try calculating the limit of the values. Can you calculate? I'll show you how to calculate. So this is left hand limit, this is right hand limit. Okay. The moment you calculate left hand limit, how do you do that? Limit x tend to 1 minus left hand limit. Okay. X plus 2. So 1 minus, that means you are putting a value which is slightly less than 1, and which would be what? Maybe you can do like this, 1 minus h plus 2. This would be what? 3 minus h, which is approximately would be 3. So your left hand limit is coming out as 3. Right hand limit, that means you are going to put a value which is slightly greater than 2, slightly greater than 1, right? So that would be 1 plus h plus 2. So this is 3 plus h. Eventually you will get 3. So limit exists. Limit exists and value is equal to 3. Right? Can you calculate this for me? Quickly. Can you calculate this for me? Can you calculate this for me? Okay, I can see 3. So everyone have direct. Yes, yes, yes. Okay. So how are you going to do? Now in polynomial function, there is a shortcut. You can call it as a ninja technique, that you simply can put the value in polynomial function. Simply just put the value, so it will become 2 square minus 3 into 2. Don't need to calculate left hand and right hand, because polynomial function usually polynomial function limit definitely exists. So this will become 4 minus 6. So this will become minus 2. Okay. So what will happen in polynomial function, and in fact in logarithmic function, exponential function, and in trigonometric function as well, you can directly substitute the value. So just quickly start putting the value. So what would be this? This would be log of x plus 2. Quickly, very small questions I have curated for you. Just let me know the answers. Log of x plus 2. The moment you plug in 0, what will you get? Log 2 is the answer. Yes. The moment you plug in pi by 2, what will you get? Sine twice of pi by 2. So this is sine pi, which is a 0. Right? Sine inverse x. The moment you plug in x is equal to half, because that's what I'm telling you. Logarithmic, trigonometry, inverse trigonometric function, exponential function, you can simply just go and put the value. No need to calculate left hand and right hand limit. Okay, so sine inverse half. Sine inverse half. Let me know what is sine inverse half. Inverse function hai. So it is pi by 6, 30 degree, right? Yes. No, I don't want, the answer will be in radians, not in degrees. You can't write sine inverse half is equals to 30 degree. Just write pi by 6. This is a more appropriate value, and this is 2 raised to power 2. So this would be 4. 4 would be the correct answer. Yes, perfect. So what was the agenda of me making you solve all of these questions? That you must understand that polynomial function, trigonometric function, inverse trigonometric function, exponential function, no need to calculate left hand and right hand. Their limit exists. You just need to plug in the values. Right? Yes? Okay. Alright. Now, there is one question which I know you guys hate. This is fractional part. Fractional part of x. Now, do you know the graph of fractional part of x? Let me just show you the graph of fractional part of x. Let me just check whether, okay, no issues. I have already created the lines. Okay. I have already created the lines. It's very difficult to make straight lines. Okay, yes. So, fractional part of x. Do you know the graph of fractional part of x? Once you know the graph, then by looking at the graph, you will be able to tell whether limit exists or not, because you have done it. In the beginning of the session, we have checked 2-3 graphs, and then we've known that whether limit exists or not. Okay. Step up curve, Shakti is saying wrong. This is fractional part of x, not greatest integer function. Fractional, no, step up curve. Ek dusre ko dekh ke everybody starts saying step up curve. This is not a step up curve at all. Okay, what is this? This is like this. The graph of fractional part of x look like this. Because the fractional part of x value stays between 0 and 1. It can become 0, but it can never touch 1. So the moment it touches 1, it is a hollow circle. Fraction. The meaning of fraction is only the same thing. That fraction means the value which is lying between 0 and 1. It can go to 0, it can become 0, but it cannot become 1. So this is the graph. It continues to stay the same. Now we are looking for x tending to 2. Can anyone tell me the left hand and right hand limit? LHL, RHL, quickly. LHL, RHL at x tending to 2. That means this value. The moment I go, okay, what is the value? Okay, tell me f of 2. Can anyone tell me f of 2? Can anyone tell me f of 2? So f of 2, I can clearly see the moment I put 2, I will get a 0. F of 2 is 0. Okay. The moment I go after 2, that means a value which is slightly greater than 2, I will still be very closer to 0. That means the right hand limit is nothing but clear cut 0. And what about left hand limit? Now be careful, be careful, be careful. Left hand limit means you have to plug in the value which is slightly less than 2. And if you plot the dotted lines, you will see that you are reaching where? You are going closer to 1. So that means your left hand limit is coming out as 1. Are you getting my point? Yes. Yes. So limit does not exist. So what we have learnt from this? Only limits? No, we have learnt the graph as well. We have learnt that the fractional part of x, the range of fractional part of x is nothing but including 0, greater than or equal to 0, but strictly less than 1. This is the range of fractional part of x. We have learnt the graph of fractional part of x. We have learnt how to decode the graph of fractional part of x. We have learned. Acha, okay, just tell me one more thing. Can I say that at every integer, on every integer, limit will not exist? Am I telling the truth? Is it correct or not? At every damn integer, limit will not exist. At every damn integer, limit. If I talk about limit of fractional part of x where x is tending towards 3, again same thing will happen. Right hand limit will become 0, left hand limit will become 1. Same value, same data. Right? If I tell you limit of this function x tending toward 3, okay? Alright. So x tending towards 3, what you will do? You will go slightly greater than, so 3 plus something, so you will be still be close to, so right hand limit RHL would be 0 and your LHL, you will go slightly lesser. So LHL will be, how do you read graphs? Is equals to 1. Okay? Right? Cool? Any problem? Any issue? Alright, there is one student who is saying confusing, ma'am. I have one more method for her, because I know there are some students who struggle with graph. They see graph and they are like, no ma'am, no mathematics, I am going bye-bye. So don't go, I have another method for you. So for example, you are looking, again this question, coming back to this question, okay. Another method, limit of fractional part of x, x tending towards 2. So what you need to calculate is right hand limit. How do you calculate right hand limit? You plug in a value which is slightly greater than 2. So right hand limit 2 plus h. Right? 2 plus h. Fractional part of 2 plus h. You all know. Fractional part of 2.00001. What would be the value? You know the fractional part. Fractional part means only fraction. No integer. Discard the integer, only fraction. So it will become 0.0001. So this will become h only. H means 0.001, which is eventually 0. So right hand limit is coming out as 0. Alright, left hand limit, for left hand limit, what you need to put is, you need to put 2 minus h, or I can say 1.9999. Yes, all the way up to 9. And only fraction, fractional part of x, only fraction, no integer, discard the integer. So this will become 0.99999 and this is very closer to 1. Left hand limit is coming out as 1. I've already told you. Right hand limit is coming out as 0. Already told you. Okay. Both methods, with graph, without graph. Okay. Done. No need to get scared from the graph. Start loving the graph. Graph will love you back. Alright. Okay. Another function, greatest integer function. I know these two functions are pain in the student's life. So, okay. Do you know the graph of greatest integer? Okay, I have actually created lines for this as well. Do you know the graph of greatest integer function? Acha, for someone, for anyone who are like first time studying the graph and not able to understand, do not worry. If it is your first time will not, it will be very difficult. If you learn it second time, then you will be like, okay ma'am, now something is like, now I am getting something. If it is first time, chill, don't, just relax. Say it is my first time, second time I'll feel some familiarity. Okay, chalo. What is, try making this graph. If you know, try creating this graph. So this is how this graph look like. Greatest integer function. This is the step up function which you all were saying. Hai na? Someone said, ma'am, step up function. This greatest integer function is step up function. Why step up function? For rest of the people who don't know why we call it a step up function, because can you see there are stairs actually. So this is 2. At 2 there is a hollow circle. 3 there is a hollow circle. Okay, 4 pe it will become, so it is 2 and 4 pe it will become like this, and it will keep on stepping up. Step up. I can climb with the help of these stairs. Okay. Now x tending to 1. LHL, that means you have to plug in a value which is slightly less than 1. Where is the graph? Where is the yellow portion? In y-axis, I can clearly see that this yellow portion is 0, is becoming 0. So your left hand limit is 0 by looking at the graph. And what about your right hand limit? So right hand limit, that means you have to put a value which is slightly greater than 1. The moment you plug in slightly greater than 1, dot, 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 so you will get a 1. So limit does not exist. Okay. And for all those people who don't want to see this graph, I have another method for you. Let's see. So limit of greatest integer function, this is method number 2, x tend to 1. So first of all, right hand limit. For right hand limit, you will plug in 1 plus h, greatest integer function. What is the job of greatest integer function? What is the job of greatest integer function? It discards the fractional part. It will only give you integer. It will become 1. Okay, LHL. Okay, so left hand limit, that means you have to put a value which is slightly less than 1. So it will become 1 minus h. Now 1 minus h is the value which is 0.999. What is the greatest integer function you will get out of this? A 0. Again, right hand limit is not matching with left hand limit. Cool. Perfect. Gautam Raj is asking me, ma'am, negative side, I am not able to understand your doubt. Please rewrite properly so that I'll be able to understand. All right. Perfect. Another question for you. Mod cortex, x tending to pi. This is a new concept actually, infinite limit. So I want you to, again, because I love graphs so much, I won't like spare you, and I will make sure that you plot the graph of mod cortex. Yes, Manish, you can definitely attend the session, and this session is helpful for JEE and boards both. But right now, we will be getting into the JEE part more. JEE part more. Yes, 2025 all students also can attend the session. Okay. Mod cortex. Let's just plot the graph of mod cortex, right? Let's just plot the graph of cortex first. Okay. So you tell me. You know tan pi by 2 is infinity, not defined. So cot pi by 2 will be 0. Can I mark this? कैसे आता है ये? उधर चला गया. Okay. Cot pi by 2 will be 0. Cot 3 pi by 2 will be 0, right? Cot minus pi by 2, cot minus 3 pi by 2, all these value will be 0. Correct or not? Correct or not? Because tan pi by 2 is infinity, so cot pi by 2 will be 0. Again 3 pi by 2, same, minus pi by 2, minus 3 pi by 2, correct? And what about cot 0? What about cot 0, cot pi, cot 2 pi, minus 2 pi? What about these values? What about these values? So tan 0 is giving me 0. Tan pi is giving me 0. Tan 2 pi is also giving me 0. So cot 0, cot pi, cot 2 pi will give me either positive or negative infinity since there is a modulus involved. So we'll just do like this. This would be the graph. And we have to plot the asymptotes at minus pi, minus 2 pi. So the graph will look like simply this. Because there is a modulus involved, there will be no graph in the negative y-axis. Okay. So pi will be asymptote, 2 pi will be asymptote, and this, yes, yes. Can you see? Now the question, in the question it is asked that x is tending towards pi. Where is the pi? This is the pi, right? We have to calculate limit at pi, right? So the moment I go just after pi, what do I see? That my limit is coming out as infinity. In fact, positive infinity. So my right hand limit is coming out as infinity. 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 And what about my left hand limit? If I go just slightly less than pi, again I'm gonna get infinity, right? So LHL tending towards infinity. Asymptote, simply asymptote means tangent, okay? The tangent where the curve will meet this particular asymptote at infinity. Asymptote means this asymptote will meet the curve at infinity. Can you go to the infinity? No. Who can go to the infinity? Do you guys know? Do you people know who is the one person who knows the infinity? I gave you the hint in the beginning of the session as well. Today is his birthday. Who is the person, who is the only person who can go to the infinity? Today is Ramanujan's birthday, and there is a film, there is a movie which is made on his life, his biography, and that movie is The Man Who Knew Infinity. The only man who knew infinity is Ramanujan. So what are asymptote? The tangent lines which will touch the curve at infinity. So I can't make it touch over here, infinity. Okay, got it? Yes. So once your exams are over, you can watch that movie for all of those who haven't watched it. Okay, alright. So limit does not, okay. So we were here. Right hand limit is coming out as infinity. Left hand limit is also coming out as infinity. Right hand limit is coming out as infinity. Left hand limit is coming out as infinity. But we know the definition. We know the definition. For a limit to exist, left hand limit should be equal to right hand limit and should be equal to finite value. Should be equal to finite value. So in this particular case, even though left hand limit and right hand limit are matching, but they are not finite value and limit will not exist. Are you getting my point? Yes? Yes, shall we proceed further? Okay, this is a homework question for you. This is a homework question for you. Limit x tend to 0, 1 by x. Limit x tend to 0, 1 by x. Okay, please note it, take screenshot. We'll proceed now. Now we have a question because since very long we are studying the concept and now is the time we should solve JEE Main 2020 question based on limits because this will help us. This will definitely help us in the examination. Okay, let's just start solving it. There's some formatting error in the options, but you are able to see the options, right? Okay, what is the question? Let us understand. Again, the greatest integer function is involved. Okay, so in the question it is given that limit of this expression modulus of 1 minus x plus this is modulus of x whole upon lambda minus x plus GIF of x. Okay, and modulus close, this is equal to L. You have to figure out the value of L. Okay, all right. People are saying the answer is 0. Let us just not jump into the answers so quickly. Let's just understand this. Okay. Let's just understand this because okay, let me just tell you 0 is incorrect. 0 is incorrect. Okay. Alright. And for all of those who are applying L'Hopital, trust me, you have to stay till the end because you will have to know that you are applying L'Hopital. This is an incorrect method. You can't apply L'Hopital over here. I will let you know where to apply L'Hopital. For that, you have to stay with me till the very end of the session. Okay. This is limit x tend to 0. Okay. So, what will you do? What I have taught you is left hand limit, right hand limit. That's what I have taught you, nothing else. We don't know anything except left hand limit and right hand limit. Is that clear? So, let's just apply that. What would be your left hand limit? Just let me know the left hand limit. Left hand limit, calculate. Okay. So, for left hand limit, you will put minus maybe h. Okay. So, 1 mod of what will it become? 1 minus, this will become approximately 0. Right? 0. Because the moment you put 0 minus h, that means a value which is slightly less than 0, it will become 0 only. Let me write it as 0 only. Okay. Mod of x, again 0. Approximately 0, I will write it as 0. Okay. Upon lambda minus 0, and this is, now here we have to be very careful. We have to be very careful. We can't write 0 over here. This is our left hand limit. Let me just tell you that if I ask you minus 0.0001, what is the value of greatest integer function of minus 0.0001? Yes, Gothram. Yes, this is minus 1. And what is 0.00001? This is 0. This is the difference. The value of greatest integer function of negative fraction is minus 1. It is not 0. And the value of greatest integer function of positive fraction is 0. So, here we need to write minus 1 and then modulus close, this is equal to L. Okay. Let me just remove the L for now. This is my left hand limit and my left hand limit is coming out as, modulus of 1 upon lambda minus 1. This is my left hand limit. Yes. This is my left hand limit. Isn't it? Now let us just calculate the right hand limit. And we are going to equate the left hand limit and right hand limit. Why? Because the question says that this particular limit is equal to L. What does that mean? If this limit is equal to L and L is a finite number, then it is for sure that limit will exist. If limit exists, then we must know that left hand limit should be equal to right hand limit. Are you getting the concept? In the question it is exclusively given that limit of this function is equal to L. If the question is screaming and telling you that limit exists, so you will say, acha, limit exists. That means LHL is equal to RHL. That's what we are doing. We are calculating LHL. Now we are going to calculate RHL and we are going to equate LHL and RHL. That's it. Okay. Cool. Put a value which is slightly greater than 0. Right. So let's put. So 1 minus 0. This will 0. This will also be 0. The value which is slightly greater than 0. I am going to put 0 only. Lambda minus 0 and a value which is slightly greater than 0. The greatest integer function of this will also be 0. That's what I have told you. And modulus is here. So this will become 1 by lambda modulus over it. These two values should be equal, must be equal for this limit to exist. For this limit to exist, LHL and RHL both should be equal. Perfect. Let them be equal. Equate them. So it will become 1 by lambda minus 1 is equals to plus minus 1 by lambda. Remove the modulus, apply plus minus line. Okay. So first take positive sign. What will you get? Lambda is equals to lambda minus 1. So this is not possible. Take negative sign. So lambda is equals to minus lambda plus 1. So this will become 2 lambda is equals to 1. Lambda value is coming out as half. So this is rejected. Why? Because lambda cannot be equal to lambda minus 1. The moment you cancel lambda, you get 0 is equals to minus 1. Not possible. So lambda is equals to half. Okay. Now there will be some people which will say, okay ma'am, half is the answer. There is another silly mistake. In the question, they have not asked the value of lambda. Especially blah, blah, blue, blow. Blah, blah, blue, blow. A student is saying half, which is incorrect. Vijay Lakshmi, A is incorrect. You are doing a silly mistake. In the question, they have asked the value of L, not lambda. What are you doing? The value of lambda is coming out as half. Okay. If the value of lambda is coming out as half, tell me what would be the value of right hand limit. So the value of right hand limit would be 1 by half ka modulus, that would be 2. है ना? And this is nothing but the limit, so L is coming out as 2. Again same thing. If you calculate right hand limit, 1 upon half minus 1, so this will become 2. है ना? And 2 is what? Left hand limit is coming out as 2, right hand limit is coming out as 2, and left hand and right hand limit is equal to L. The value of L is option C. Googly done? Googly question? Googly question? Blah, blah, blue, blow. All right. Cool. Done, dusted, perfect, sorted. Chalo, indeterminate form. So, if I talk about limits, there are 7 indeterminate forms. Right? There are 7 indeterminate forms. What are those forms? 0 by 0 and infinity by infinity. These two are my favorite forms. 0 by 0 and infinity by infinity. Cipher is saying why plus or minus in the RHS? Because modulus was there, na? Because modulus was there. The moment you remove the modulus, you have to apply plus minus sign cipher. ठीक है? I hope the doubt is clear. Okay, we have 7 indeterminate forms. Okay, 0 by 0, infinity by infinity. The very important forms. Once you know these two forms, all these forms will be taken care of. These two are the king of all forms. And then, once you know these two forms, all the forms are interrelated. Right? Got it? Just learn technique of these two, and these two will be a slightly similar techniques I will share with you, the rest 5 forms. First of all, let's understand 0 by 0, infinity by infinity, infinity minus infinity, 0 multiply infinity, 1 raised to power infinity, 0 raised to power 0, infinity raised to power 0. Why these 7 forms only? Why these 7 forms? Why these 7 forms? Let me just ask you, why not infinity raised to power infinity? Why this form is not here? Why only these special 7 forms? What is so special? What is so special about these 7 forms? Okay, one student is asking, Sakti is asking, why not plus minus in left hand side? Okay, there is one doubt related to previous question, I guess, plus minus sign. So, Sakti, there is a property of modulus function which is mod x is equals to mod a. If this is the situation, then you have to apply plus minus only on one side. Why? Because even if you apply plus minus on the left hand side, it won't make any sense. Are you getting my point? It won't make any sense. You have to apply plus minus only at one side only. Because if you apply both the sides, so same thing. First thing will be x is equals to plus a. Second thing will be x is equals to minus a. That's what we have did. That this is equals to plus thing and this is equals to minus thing. Only 2 possible things, right? Ma'am, Telegram channel link not working. Okay, let me just figure out after the session. Okay. Okay, we were studying these 7 indeterminate forms, right? 7 indeterminate. I was asking you, why not this? or why not infinity plus infinity? What is so special about these 7 and why all these forms, there are multiple forms which I am not able to include over here. Why? My question is this. So let me just answer you. What happens is, if I carefully observe infinity raised to power infinity, this particular value or simply infinity, this infinity I know will go to, this is a very large value. Okay? This is also a very large value. This is also a very large value. And if I talk about 0, this is very small, tending towards 0. Very small values, right? The difference between these forms and these 7 indeterminate form is this, that these people know that where to go. These people are not confused. These people are not confused, but all these 7 people are confused. All these 7 indeterminate forms are 100% confused. How? Let me just show you. Just tell me one thing. If I say that the numerator is 0 and denominator is finite, then the value will go towards 0. Agreed or not? 0 upon 1, 0 upon 2, 0 upon any finite quantity is equal to 0. Yes, do you agree? When the numerator is 0, the whole fraction will tend towards 0. Okay, alright, perfect. And any finite quantity upon 0, for let's say 1 upon 0 or 2 upon 0. Finite quantity upon 0. If the denominator is 0, we say okay, it will go towards infinity. Either plus or minus, that will depend, but plus minus infinity. Yes? Okay. So that means when numerator is 0, we want the whole fraction to go towards 0. When the denominator is 0, we want the whole fraction go towards infinity. That means 0 by 0 here, the numerator is also 0, denominator is also 0. So numerator wants this whole fraction to go towards 0 and denominator wants the whole fraction to go towards infinity. That means this is super duper confused. This indeterminate, now you understand, indeterminate, we can't determine where this 0 by 0 is going, we can't determine infinity by infinity is going, but we can definitely determine this infinity raised to power infinity is going towards very large quantity. This particular thing is not confused. That's why only these 7 forms, and I have actually curated some more forms which are not at all indeterminate form. Let's just see. Infinity into infinity. Can you see? This is a very large value. Infinity plus infinity, not at all confused. Sorted. Infinity. Okay. A upon infinity, 0. Infinity upon tending towards 0, infinity. Right? Can you see that these all forms are not at all confused? Infinity raised to power infinity will go towards infinity. Okay? These are not indeterminate forms. Only these 7 forms. Okay. Take the picture, take the screenshot, paste this 7 in your brain. Take the screenshot and paste in your brain, in your head. Ma'am, what about 0 raised to infinity? So 0 raised to power infinity is not at all indeterminate form. Mohammed Noble, very good question. Very good question. 0 raised to power infinity. Now there are 2 ways to go about it. If this, actually 3 ways. 0 raised to power infinity. Exact 0 raised to power infinity. That means you have exact particular 0 and you are giving the power infinity. That means you are multiplying 0 infinite times. You are multiplying 0 infinite times. What would be the result? 0. Okay. 0 plus raised to power infinity, that means there is a small fraction. For example, 0.1. Do you have calculator at your place? If you have calculator at your place, 0.1. Just multiply 0.1 into 0.1 into 0, keep on multiplying, you will realize that this particular thing will become even lesser and eventually tend towards 0, and minus 0.1 raised to power infinity, again this will become what? 0. So this is not an indeterminate form. Everything is tending towards 0, everything is tending towards single thing. Okay. Cipher, how can nothing be multiplied infinite times? Just like nothing multiplied by infinite times will give you nothing. Alright? Okay. Cool. Now, in the beginning, I have already told you that there are two king forms, 0 by 0 and infinity by infinity. 0 by 0 and infinity by infinity. 0 by 0 and infinity by infinity. These two are very, very important forms, and these are the methods which we will use to solve 0 by 0 and infinity by infinity form. Now listen to me carefully, very important, very important. Very important. Stop chatting. Stop writing anything in the chat box. Listen to me very carefully. The moment you see any problem from the chapter limits, what should be the first thing you do? The moment you see in the question paper, JEE Main 2024, suppose you are sitting in the examination hall, you are seeing a question from the chapter limits, what exactly will you do? One student is saying, L'Hopital. No, you will check form of that particular limit first. The very first thing is you have to check form of that limit. What is the form of that limit? Which indeterminate form is that particular question is forming? I will show you how to do that, because once you know the form of that limit, then only you will decide that which method to apply. Because I am already telling you that there are multiple methods: factorization, rationalization, substitution, L'Hopital, series expansion. All these methods are for 0 by 0 and infinity by infinity form. And one student was applying L'Hopital in the previous question without even knowing whether that form was 0 by 0 or infinity by infinity or not. That's why the student got incorrect answer. Because he saw the question, he straight away applied L'Hopital rule. I know you know L'Hopital rule very well, but realize where to apply the form. Right? Okay. So 0 by 0, infinity by infinity form. Let's just start the very first method, rationalization, the very first question, and here we go. So I have already told you, the moment you see any limits question, what will you do? You will first check form of that limit. Even in JEE Advanced question, there was a question in JEE Advanced 2016 or 15, I am not sure, where you just have to check the form of that particular limit and then answer. Students didn't do that and they got incorrect answer. I will tell you in the upcoming question. Okay, so what is this form? Tell me the form of this limit. The moment I plug in 2 over here, 2 square minus 4 upon 2 minus 2, so this will become 0 by 0. 0 by 0 form. For 0 by 0, we have factorization method or rationalization method. Start just factorizing. So x plus 2, x minus 2, we have done that, upon x minus 2. We can clearly apply this. Limit x tend to 2, cancel this. So this will become what? Limit of x plus 2, x tend to 2, plug in the value, 4 is the answer. Yes, I know 4 is the answer. Perfect. I know you know this method. I know you know this question. I know you are thinking that, ma'am, this is very easy question. I agree. But what I am trying to tell you is always check the form of this particular limit. Okay. Now tell me this. What would be the answer? Quickly, quickly, quickly. Now we are going to like pick the pace. Now I'm going to be super fast. Super quick, super fast. Next chapter, I'm going to reveal the next chapter by the end of the session. Okay, so check the form of this particular limit. What is the form? So the form would be root 0 would be 0 upon root 4 minus 0 would be 2 minus 0. How to check form? Just put the limit. Just put this particular limit in this. So this will become 0. This is not an indeterminate form. Why to apply rationalization? One student is writing rationalization. No, 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 no. We can't apply rationalization. That's what I am telling you. Is this an indeterminate form? No. This question is trying to make a fool out of you. Vamsi, again, I already told you the very first thing, that's why I told you. The very first thing which you are going to do the moment you see limits question, no rationalization, no factorization. That is the later step. What would be the first step? Identify the form. Once you know the form, then only you apply. Okay, which method should I apply? Okay, got it? JEE Main September to 2020 question. Okay, let's just start solving this question. So the very first thing which you are going to do is check the form. Check the form. So the moment you plug in x equal to 2, you will get 9 and then plus 3 minus 12 upon 1 by 3 and then minus 1 by 3. So this is 0 by 0. All right. Yes, this is a proper indeterminate form. Now we are happy, right? So for that, now we need to solve it with the proper technique. What should be the proper technique? I can see there the question, by looking at the question only, I can understand that I need to take something common, isn't it? We need to take something common. Factorization, we need to do some factorization because rationalization is not applicable. Factorization is the only thing which is left. But I can see the question seems a bit complicated because 3 raised to power x is involved, 3 raised to power x by 2 is also involved. So why not do one thing? Why not just simplify it and put 3 raised to power x by 2 is equals to t? Why not just simplify it and put this substitution to just simplify the look and feel of the question. Okay. Yes, a student is saying take common. Yes, that also you can do. Okay. So I'm going to just simplify once. Limit x tend to 2, 3 raised to power x. So let it be like this, plus 3 raised to power 3. 3 raised to power 3 would be 27 upon 3 raised to power x. Can I write it this way? 3 raised to power 3 minus x. So 3 raised to power 3 is 27. 3 raised to power minus x would be 3 raised to power x in the denominator upon 12 whole upon 3 raised to power minus x by 2. So this would be 1 upon 3 raised to power x by 2. And what about this? Minus 3 upon 3 raised to power x. This is the simplified version. Okay, now just start putting this. The moment you put x equal to 2 over here, you will get t is equals to 1. Sorry, t is equals to 3. Where x is 2, your t is coming out as 3. So I am converting this whole limit in terms of t. Can I do that? T tend to 3. Now this will become t square plus 27 by t square minus 12 upon. This is nothing but 1 by t minus 3 by t square. Take LCM, just solve it. You will get the answer. You will get the answer. So this will be t raised to power 4 minus 12 t square plus 27, right? T square is LCM, that will get cancelled out. So this will become t minus 3 and limit t tends to 0. T tends to 3. Can you see the question has become more simpler? Can you see? Can you see? Can you compare these two? This was looking scary. This is looking familiar. We are familiar with square, t square. We are not familiar with exponential, that's why I did that. Now we just need to factorize t raised to power 4 minus 12t square plus 27. You know the factorization, 9 3s are 27 and 9 plus 3 12. So t square minus 3 and t square minus 9. Right, 9 3s are 27, 9 plus 3 12. Correct. Upon t minus 3 and limit t tends to 3. Perfect. T square minus 3. Now factorize this, t plus 3, t minus 3 and then t square minus 3. Okay, I have factorized this. A whole upon t minus 3. T minus 3 gone. Put the value of t over here. So 3 plus 3 6. T square minus 3 is also 6. 36 is correct answer. JEE Main 2020 question done nicely. 36 correct answer. Do let me know in case any doubts. No, 0 is incorrect. Why 0? Why 0? Why 0? I can understand 0 by 0 form is getting formed. The moment you plug in 3, this will become 9 minus 3, 6. This will become 9 minus 9, 0 and this is 0. But here we need to factorize. Here we need to factorize. Here we need to factorize 36. Why I am not able to write 6? Are you getting my point? See, this, if you split this, okay, let me just do once again for you. One more time. I will do it one more time. One more time. Okay, so just split this. Once you split this, you will get t square minus 9 and t square minus 3 whole upon t minus 3. Do not hurry in this step, do not hurry. Limit t tend to 3. Clear till here? Clear till here? Yes. Now t square minus 9 and t minus 3. Abhi bhi if you put t tend to 3 now, you will get 0 by 0. Abhi bhi still till here you get 0 by 0 form only. So what you need to do? 0 by 0. How to tackle 0 by 0 form? Factorization. T square minus 9, factorize it. T plus 3 and t minus 3 will get cancelled out. I am not writing. T square minus 3. Correct? Limit t tend to 3. Right? T square minus 9 I have factorized. T plus 3. T minus 3 will get cancelled out with denominator. Gone. I am not writing. T plus 3, t square minus 3. Put the value of t is equals to 3. What do you get? 3 plus 3, 6. Multiply. 3 square is 9 minus 3, 6. 6 into 6, 36. Not a single correct answer. Yeah, this actually, Gotram, this is the step where many students make mistake. You are not the only one. You are not the only one. This is the most vulnerable state of a student. This is most vulnerable state of students because here they understand that, oh my God, boom, I got the answer. And that's when you make a silly mistake. That's why we call it a silly mistake. And now Mani is asking that, ma'am, why t is tending to 3? Let's see here. X is tending towards 2, right? The moment you put x equal to 2 over here, you get 3 raised to power 2 by 2. So 3 raised to power 2 by 2, that means t is equals to 3. Perfect. It's better if you are able to take the notes, but I will definitely share these notes with you as well. But if you make your note, MD Safin, repeat, substitute, process. Nothing. I just saw this question. I saw so many 3 raised to power, so many 3 raised to power x. 3 raised to power x, 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 and I got scared. Just like you, I got scared. Just like you, I got scared. I decided let's put something. Let's just get rid of 3 raised to power x. Then I decided, okay, 3 raised to power x if I put na, though I will not I'll not be happy. I should put 3 raised to power x by 2. The moment I put 3 raised to power x by 2, what will happen? If I square both the sides, then 3 raised to power x will become t square. Right? So 3 raised to power x is what? T square. Can you see? 3 raised to power x is t square. And what is this? 3 cube upon 3 raised to power x. So 27 upon t square. 12 I have copied as it is. 3 raised to power minus x by 2. That means 1 upon t. Then what is this? 3 raised to power 1 minus x. So 3 raised to power 3 upon 3 raised to power x. So 3 by t square. Can you see that? Now just take LCM. The moment you take LCM, you will get this. Now this is something which is quite familiar with you, isn't it? Just factorize, cancel out the terms, put the value of t. That's it. I can see some students are discussing chemistry over here. Why are you doing this with me? Why are you doing this to me? Why are you doing this to me? Okay, another question, JEE Main April attempt 2019. Okay, can you see the square root involved over here? But again, the moment you see limit question, what do? Check form. The moment you see, so 0, this will become sine square 0, so numerator is coming out as 0. The moment you plug in 0 over here, 1 plus 1, 2, the root 2 minus root 2 will become 0. Form is 0 by 0, and we can clearly see that we can apply rationalization for this particular question. Okay, Lambo is saying, ma'am, for any exponential we can apply direct limit. No, I am saying exponential function. This is the combination of exponential function. This is not an exponential function. This is a combination. If you see direct exponential function, apply. If you see direct polynomial function, apply. But if you see polynomial upon polynomial, don't apply. Okay? Chalo, let's just, students are saying increase the speed. So this is the question, 0 by 0 form. Clearly I can see that we can apply what? Rationalization. So limit x tend to 0, sine square x upon root 2 minus square root 1 plus cos x. Correct? And then just multiply, okay, with the conjugate. We need to multiply the conjugate. So root 2 plus root 1 plus cos x and root 2 plus root 1 plus cos x. That's how we rationalize, right? We just take opposite sign, and opposite sign is what? Positive sign. So plus se multiply and divide. Okay. Now what is the denominator? This is a plus b, a minus b. So this will become root 2 square 2 minus 1 plus cos x. Correct? So it will become what? 1 minus cos x. In the denominator, perfect. 2 minus 1, 1 minus plus minus. 1 minus cos x. Alright. Sine square x is as it is. Okay. So sine square x I can write it as 1 minus cos square x. And this is already there, root 2 plus root 1 plus cos x. Okay, limit x tend to 0 is already there. Now, 1 minus cos square x can be written down as, can be further factorized at 1 minus cos x, 1 plus cos x, okay, and this root 2 plus root 1 plus cos x. 1 minus cos x, 1 minus cos x gone. The moment you plug in x is equals to 0, what do you get? 1 plus cos 0. So this will become 2. This will become root 2 plus root 2. So this will become 2 root 2. That's it. So this is nothing but 4 root 2. Option C. Done, 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 done. Perfect. Option C correct. Getting the confidence in the chapter, in the topic limits. Okay. All right. Now there are some standard limits which I want you to remember till the end of the JEE exam. Okay. All right. The very first limit is sin x by x is equal to 1, right, where x is tending towards 0. Sin x by x is equal to 1, where x is tending towards 0. This is the very first limit. Tan x by x is equal to 1, where x is tending towards 0. Okay. So one thing you should understand that sin 0 by 0 is 1. Remember like this. Sin 0 by same 0 is equals to 1. Yes, a student is saying till that. That's what I wanted to say. But I controlled myself. Can you explain this reason, ma'am? Which reason are you talking about? This reason? This I will explain. All the reasons I am going to explain. Don't worry. Sin x by x is coming out as 1. Tan x by x is coming out as 1. So tan 0 by same 0 is 1. Right now, this is my favorite. This is my favorite. This is your Ninja Ma'am's favorite. 1 minus cos x upon x square. That means 1 minus cos 0 upon that 0 square is nothing but half. 1 minus cos 0 upon that 0 square is half. Alright, all three remember? All three understood? These three are from same category. Alright, cool. Now let's go to this. Let's go here. Abhi, we don't have time for the derivation. You have exams. I will derive it some other day for you definitely, but not in this session. Okay. Never use L'Hopital when you are studying first time limits. I will let you know where to use L'Hopital. We will definitely use L'Hopital. Don't worry about that. Okay. So this e raised to power x minus x upon x. That means e raised to power 0 minus 1 upon same 0 is coming out as 1. A raised to power 0 minus 1 upon 0 is coming out as log A. Actually, what is happening over here is this is coming out as log E. These two are related and this is coming out as log A. Same. E and A. Only the difference is E and A. E raised to power 0 minus 1 upon 0 is log E. A raised to power 0 minus 1 upon 0 is log A. Correct? And log E is what? Ln E is 1. So both are from same family. Correct? Log 1 plus x upon x. So that means log 1 plus 0 upon 0 is 1. And when I am telling you, when I am teaching you this, I am spending some time in this. I will ask some question based on this after this particular slide. So better be careful. Better pay attention over here. Okay. So log 1 plus x upon x is coming out as 1. Correct? All three remember? 1, 2, 3 sorted. 1, 2, 3 sorted. Okay. Explain third. Log 1 plus 0 upon 0 is equal to 1. Okay. Alright. Okay. And this one. These two again are from same family. Right. What is the form of this limit? Are you able to identify the form of this particular limit? How do we do that? The moment you plug in 0, you get 1 raised to power infinity form. And same 1 raised to 1 plus 1 by infinity. So this is nothing but 0 and this is infinity. So though both are 1 raised to power infinity form, both values are coming out as E. Yes, for 0 by 0 you can directly use L'Hopital. So these two belong to same family, 1 raised to power infinity form. One is extending to 0, another is extending to infinity. Here it is x, here it is 1 by x, here 1 by x, x. Same thing. Alright? And E. Correct? So 1, 2, 3, 4, 5, 6, 7, 8. Ninth formula, which is this. Okay? X raised to power n minus a raised to power n upon x minus a, where x is tending towards a. Right, so let me just give you an example. If I ask you x ki power 5 minus minus 2 की power 5 upon x minus 2. Limit x tending to 2. If this is the question, can you see that here the power is, here x minus 2, power is 5 each, and here x minus 2. So what would be the answer? How to remember it? So write power into limit and raised to power minus 1. So that is 4. What is the power? 5. So answer would be 5 into limit. What is the limit? 2. And this power of 2 would be what? 4. So 5 into 2 raised to power 4. Are you getting my point? One more example. X raised to power 10 minus 3 raised to power 10 upon x minus 3, limit x tend to 3. What would be the answer? Tell me. What is the power? 10. What is the limit? 3. Right? And 3 raised to power this particular number minus 1. 10, 3 raised to power 9. Perfect. All the formulas remember? Everything sorted? Yes? Let me know. Take the screenshot of the formulas. You have to remember all these formulas plus 2 more formulas, which are sine inverse x by x is also 1, limit x tend to 0, and tan inverse x by x is also 1, limit x tend to 0. Only these formulas I want you to remember. Take screenshot if you want to. Alright, now practice time. Practice time. Quickly, quick practice. Okay, what is the form? Always check form. Always check form. The moment you put 1, what you get? So this is becoming sine 0 by same 0, which is 1. Sine 0 upon same 0 is 1. Okay. What about this? What about this? How to solve this? Everyone should know how to solve this. Every one of you. This is must for everyone. Okay. So this is sine 2x. Right. That means sine 0 is getting formed. So what I need in the denominator? I need 2x and okay. Right. And this is 3x. So I need actually, so let me just do it this way. So this is sine 2x and this is tan 3x. Correct? Sine 2x will need a 2x in the denominator. Tan 3x will need 3x in the numerator. Okay? But this is the new term I have divided by 2x. So I need to multiply it by 2x. 3x is here. So 3x I need to do. So what I did in the whole sine x, sine 2x by tan 3x was the original question. Right? Okay. And I have divided by 2x, so multiplied by 2x. I have multiplied by 2x, so divide by 3x, so that the whole question is intact, the same. Right? Sine 2x by 2x, limit x tend to 0 is 1. This is also 1. This is x gone 2 by 3. So 2 by 3 is the correct answer for this particular question. Cool? Done. Vaishnavi, incorrect. There are some students who are still getting it wrong. 3 by 2 is incorrect. Please be careful. Please be careful. This is very easy. Very easy. Right? You have divided by 2x. This is gone with sine 2x by 2x. This is 1. This is also 1. So 2x in the denominator. So 2x in the numerator. 3x in the denominator. 2 by 3. That's it. 2 by 3 is the correct answer. Are you getting my point? Are you getting my point? A student is saying, ma'am, you please, LVS is saying pen color. Is pen color is troubling you? Pen color is creating some problem? Do let me know. I don't think so. I can see the letters nicely. Okay. One more question. Now we will apply shortcut. Ninja technique. Okay. This is tan inverse 5x. So the answer would be what? So 5x would be in the, I will need 5x in the denominator. This will go with tan inverse. So 5 will be in the numerator and 1 by 4. So directly you can write 20. Can you see that? This is a ninja technique. This is a ninja technique. 5x, 5. X by 4, 1 by 4. 5 4s are 20. Correct? Here also you can do the ninja technique. 2 by 3. Perfect. Alright. Shall we move to the next question? Quick solution. Again, this shortcut I have already told you. This shortcut I have already told you. X raised to power 10 minus 1 upon x minus 1. So this is 1 raised to power 10. Now what will you do? Tell me the shortcut. So power into limit raised to power minus 1. Power into limit raised to power minus 1. So this is 10. Okay. This is 10. Now here dual question is here. Dual type of question is here. So you need to separate it out. X raised to power 10 minus 2 raised to power 10. For this you need x minus 2, right? And for this x raised to power 5 minus 2 raised to power 5, you need x minus 2. Balanced it out. It is all automatically balanced. X minus 2 will get cancelled out. We'll get back to this, right? So now what is this? Tell me. So 10, that means power into limit power minus 1 upon power is 5, limit is 2, power minus 1 is 4. 5 and 2. So 2 raised to power 10 upon 2 raised to power 4, 2 raised to power 6, 64. Done. Done. Are you having fun? So many incorrect answers. I am super duper disappointed with you guys. 8 multiply 8. Yeah, 8 multiply 8 is correct. Sorry, 64. 2 multiply 30. Okay, correct. So sorry. I thought 8 raised to power 8 you are saying. 8 multiply 8 is correct. Perfect. Blah, blue, blee, blue. Chalo. So we have another question on our plate. This question, yes. This question. Thoda formatting is thoda sa off, but you can see the options. JEE in 2019, please do this question. 2 minutes. I am giving you 2 minutes. Okay? 2 minutes. Start solving quickly. Mistaken question. No, I can see question is correct. No mistake. I can see so many. Okay, all right. So just tell me about this. If these two limits are equal, we just need to do the calculation. I hope you understood the question. There is nothing to explain in the question first of all, in the very first place. Okay. So this will become what? Power into limit raised to power minus 1. What about this? So for this particular question, I will need x cube minus k cube is already there. I will need x minus k in the numerator. And we have x square minus k square. So I need x minus k so that I can apply the formula. So this is another formula. This is another formula. Let's just apply this formula. 4 would be equal to. So this will become power into limit raised to power minus 1 upon. What about this? Power is 2. 2 into limit and power minus 1. So power minus 1 will become this. So this is nothing but 4. This will get cancelled. 3k by 2. 8 by 3 is equal to k. Clear cut answer. Very easy. And bingo, option B is absolutely correct. Yes. Ma'am, what happens if plus sign between them? If plus sign is there, account is asking a very good question. If plus sign is there, I have already told you, account, I have already answered this particular question. If you have plus sign and if you try to identify the form of this particular question, what will you get? The moment you plug in 1, 1 plus 1, 1 plus 1 is 2. 1 plus 1, 2. So this will become 1. What about this? If it has plus sign. So k cube plus k cube, 2k cube upon 2k square. Are you getting my point? So 1 is equals to k की value 1 आ जाएगी. The value of k will be 1. Because this will not be an indeterminate form if you are asking about the plus sign. If instead of minus sign, the question is asking you to calculate for the plus sign, positive sign, then that won't be a question from indeterminate form. That is a very random question. It is a class 9 question. It will become class 9 question. Okay. So now we have actually tackled rationalization, factorization. Now here comes your favorite L'Hopital rule. Here comes your favorite L'Hopital rule. Okay, let's just dive into the L'Hopital rule. Fatafat se quickly, be super quick in telling the answer of this particular question. Quickly in the chat box. In the chat box, do let me know. Do let me know the answer of this particular question. Quickly, be quick. Okay, I am super duper happy. I can't tell you, I am so happy. This is the, I guess, one of those classes which have given me the correct answer of this particular question. And I will take some credit for this also, because in the beginning I have already told you that no matter what happens, always check form, identify the form, right? So there are many students I ask this question in each and every class of mine. You go to every class of mine, you open every class of mine on YouTube, okay? I ask this particular question every time, and every time, trust me, I get absolutely incorrect answers. What I get is, I get L'Hopital rule, okay? So minus 4 by 9. There are some students who are still thinking. Because it's like L'Hopital rule, okay ma'am, L'Hopital 0, 0, minus 4 by 9, done. Okay, but you can't apply L'Hopital rule over here for all of those who are still trying to understand what happened over here. So you can't apply L'Hopital rule over here, because to apply L'Hopital rule, you have to check the form 0 by 0 or infinity by infinity. So the moment you check the form, you will realize this is 0, this is also 0. So the value directly coming out to 1 by 3, this is not at all an indeterminate form, no 0 by 0, no infinity by infinity. No, I am not at all disappointed. I am super duper happy actually. Alright. Okay. So L'Hopital rule, let me just explain you the L'Hopital rule, that where to apply. So for example, you have the situation where limit x is tending towards a, f of x upon g of x. Alright. Now, if your fx is tending towards 0 when your x is tending towards a, and your gx is also tending towards 0 when your x is tending towards a. That means the moment you plug in a, both are becoming 0, then you can simply differentiate all the functions individually, f dash x upon g dash x, and it will become f double dash x upon g double dash x till your problem, till your indeterminate form get dissolved. Okay, triple dash 4 times, in how many times you can differentiate, and this is applicable for infinity by infinity form as well. Okay, all right. Now the explanation part. Some students wanted to understand why sin x by x is coming out as 0. So sin x, derivative of sin x is what? L'Hopital we are applying. Cos x upon 1, the moment is a cos 0 is coming out as 1. L'Hopital rule in the standard function. Okay, alright, that's how we apply L'Hopital rule. So this will become what? So cos x upon 1, which will be cos 0. Tan x, so this will become sec square x upon 1, sec square 0 is 1. Okay, 1 minus cos x upon x square, this is 1 minus cos x, right? This, remember, this was my favorite. Remember, this was my favorite. What is the answer? Can you recall? I just showed the answer. I just told you to remember this. What is the answer? 1 minus cos x upon x square. So you can apply L'Hopital over here, minus sin x plus sin x upon 2x. Sin x upon x is 1, so 1 by 2 is your answer. Right? Next, log 1 plus x upon x. So the derivative of this is 1 upon 1 plus x. And the derivative of x is 1. The moment you plug in x equals to 0, you will get 1. Okay, e raised to power x minus x. So the derivative will be e raised to power x. And the moment you plug in x equal to 0, you will get 1. That's it. That's it. Have a look. All sorted? Yes? All right, all right, all right. Let's go back one more question. JEE Main 2023. 2023. That means this year, latest question for you people. You know what? I have full faith. I am I'm expecting a lot from you, and I'm expecting that majority of you will get the correct answer for this particular question. That's why I am ready to give you 2 minutes, but what I expect is correct answer. Correct answer. Yes, quickly. Correct answer from this particular question. Vijay Lakshmi is saying 9. Naga Sai is saying 18. All right, all right. What about others? You're getting complete 2 minutes. If you're getting complete 2 minutes, don't give answer in 1 minute. Only give when you are 100% sure. So I can see there is a 50-50 tie between 9 and 18, option B and C. Some are saying B9 and some are saying C18. These two answers are frequently given answers. Yes, 9, 18, 9, 18. Let's just see what happens. Okay. Okay. All right. Which pen? Okay. Green this time. 1 minus cos square 3x. Can I write it as sine square 3x? Yes. And this is what? Cos cube 4x. Now, okay. Have you checked form of this limit? Have you checked form? So this is giving me 1 minus 1, 0. So upper numerator is 0. This is also 0. This is also 0 because log 0 plus 1. So log 1 is anyway 0. So 0 upon 0 form. 0 by 0 form is getting formed, I know. Right? I am writing this as sine square 3x. Then cos square, cos cube 4x. The moment you plug in x is equals to 0, it will become 1. So this is not a trouble for us. This is not at all trouble for us. Anytime if I am going to put x tend to 0, this will give me 1. Right? So I will anyway write it as 1 only directly. Because this is nothing, this is 1. Straight away I am writing it as 1. Okay? Cool. What about this sine cube 4x? Okay, so sine cube 4x. Perfect. And what about this? This is ln 1 plus 2x. Let me just raised to power 5. By the way, raised to power 5. Let me just remind you one thing. Let me remind you the standard limit. ln 1 plus x upon x. That means ln 1 plus 0 upon same 0 is 1. Limit x tend to 0. This is the standard limit which we have studied. So what I need over here is 2x. Power 5 is already there. The moment I have multiplied 2x in the numerator, I have to divide. So 2x raised to power 5, correct? To compensate. Perfect. 2x, 2x. Whatever I do in the numerator, same thing I am going to do in the denominator. What about this? Because limit x is tending towards 0. So this will need 3x square in the denominator. So I will need 3x square in the numerator. Right? Yes. What about this? 4x cube in the numerator. So 4x cube in the denominator. Perfect. Now tell me, this will become 1, gone. This will become 1, gone. This will also become 1 with power 5, gone. And this is already 1. So all these boxes are becoming 1. The only thing which is left with me is this portion. I just need to solve this question and I am done. Okay, so x square, x cube, x raised to power 5. Clearly we can see numerator is having x square and x cube. So x raised to power 5. Denominator is also x raised to power 5. X will not be the problem for us. So 3 square is 9. 4 cube. So 64 upon 2 raised to power 5, 32. So this will become 18. 18 is the correct answer for this particular question. Alright, okay. Now I have already told you a ninja shortcut, right? So this is one, okay. This I am not taking into consideration. This was sine square 3x, right? This was sine square 3x. So I need a 9 for this. Square है ना, इसलिए I need a 9 for this. I need a 4 cube for this, and I need a 2 raised to power 5 for this. So 9 into 64 by 32, 9 into 64 by 32, 18. Directly you can answer this question. Directly, ninja technique, killed. Kill, kill, kill. We have killed the question. We have actually, we have killed the question, right? But we booked the session. No class. Paul sir की कोई class नहीं है आज. I'm having it. All right. Perfect. All right. So L'Hopital done nicely. Okay. Series expansion. Now next method for 0 by 0 and infinity by infinity form is series expansion. So you have to, for me, you have to do one thing. You have to remember the series expansion, because trust me, it will definitely help you in your JEE main paper. But if you don't remember it, it will cost you some good chunk of marks. So don't do this mistake, because I see some students say ki okay, I have another methods, I have L'Hopital, I have factorization, I have rationalization. So remembering series is a very difficult task. So let's just skip this particular portion. Don't do that. I am here to make you remember all the series. Okay. E raised to power x, the very first series, very basic. This to every student should remember. e raised to power x is equals to 1 plus x by factorial 1 plus x square by 2 factorial plus x cube by 3 factorial and so on all the way up to infinity, right? Now a raised to power x, a raised to power x, same family. You just have to replace x by x log a and you are sorted. E raised to power x, a raised to power x, same. You just have to replace x by x into log a. x square की जगह x square log square है, x cube की जगह x cube log cube है. Rest everything is same. These two 100% promise, ninja promise that you will remember these two till your exam, till your JEE main second attempt, and well, actually post that I don't need to say anything because once you are done with your JEE main, I know you will be serious for your JEE advance. So my responsibility till JEE main, please remember. Okay? Alright? Post JEE main, I am automatically coming into the picture. I'll make sure that for JEE advance, you're going to kill next things. Okay? Alright. Log 1 plus x. Log 1 plus x. Log 1 plus x. So remember in log 1 plus x, there is an alternative plus minus sign. It starts at plus minus plus minus plus minus. So log 1 plus x starts with x. It doesn't have any constant term, remember this. Log 1 plus x start from plus x. Just remember this. Okay, and alternate sign, here there is no factorial. Here is factorial, but in log 1 plus x there is no factorial, right? So x minus x square by 2 plus x cube by 3 minus x ki power 4 by 4 and so on all the way up to infinity, right? Yes, okay. If you want to take the screenshot, take the screenshot, and then here is a Maclaurin series. So Maclaurin series, this is the formula to calculate all the series. But if you are someone who says, okay, I'll remember only the Maclaurin series, I won't remember this. This is not the way things work. This Maclaurin series is just for slight hint. Maybe you forgot some particular term or some formula. In emergency case, if you're forgetting anything, then you can use the Maclaurin series. I will show you how to use it. So for example, you have a function fx is equals to e ki power x, right? Now, the very first term in the expansion series expansion will be f of 0. Now, what is f of 0? E raised to power 0. So, first term will be 1 plus f dash 0. Now, what is f dash x? Tell me, f dash x is also e ki power x. F double dash x is also e ki power x. So, f dash 0 is also 1. So, 1 into x by factorial 1. Yeah, what will be this? This is also 1. So, x square by factorial 2. Are you getting my point? X cube by factorial 3. That's how you apply Maclaurin series in any of the expansion, but this is just for an emergency. This is not a substitute so that I won't remember any expansion. I'll remember only Maclaurin series. It won't work like that, trust me. It won't work like that. Some more series expansion. Okay. Sin x and cos x. Same family. Okay. So, sin x is all about odd because sin x is an odd function. Sin x is all about odd terms. Alternate plus minus, but all the odd terms. Okay. And cos x is all about even terms, the left out terms, alternating plus minus, that's how you remember. Because cos x is an even function. So these two are very easy to remember. Sin x, odd. Odd means, okay, odd starts from 1, so x ki power 1. Alternate plus minus sign, so minus x cube by 3 factorial plus x ki power 5 by factorial 5. Next term would be x ki power 7 by 7 factorial with a minus sign. Same goes with cos x. The very first even term would be 1, then x square by 2 factorial, x ki power 4 by 4 factorial, plus minus sign will go. Then this tan x is something which is a pain. I also agree. But only 3 terms. Only 3 terms. Please remember only 3 terms. X cube by 3, 2 by 15 x raised to power 5. Only 3 terms. Only 3 terms. Only 3 terms. I know this is pain. I agree, but a little bit pain. For me, for JEE Main 2024, I am sure you will do it. You won't break my promise. You won't break Ninja promise. Okay. So these 3 things and these 3 things. Right? Only 6 expansion in this particular session I am I want you to remember. Okay. Alright. Perfect. 2 more expansions. 2 more expansions. Actually one more. This one. Not 2. 1. Okay. So this expansion I know, I am sure that many students, you all know this. This is nothing but binomial expansion. Binomial expansion, and this is love. This is love. Binomial expansion. You have no idea that how much I am going to use this. You have no idea how much I am going to use this. You have no idea how much I'm going to use this. Student is Captain Shreyas for JEE NEET. Ninja ma'am, take my name. I guess this is a fake profile of Shreyas sir. No, Shreyas sir in the chat box. All right. All right. Okay. Perfect. So, binomial expansion, you have no idea in this particular session how many times I'm going to use this particular binomial expansion. And you know what? I am not asking you to remember the whole formula. The priority is to remember only this. 1 plus x raised to power n is approximately equals to 1 plus nx. Right? One more term. If you remember this, I'll be very, very grateful to you. n minus 1 x square by 2 factorial. This is just your binomial expansion. Do you remember this? Right? Okay. So this is the formula I want you to remember. Perfect. All right. Let's just start applying series expansion now. Let's just start applying let's just start solving series question. Okay. So what is this? Tell me. So this is a 0 by 0 form. I know that you'll be able to do this by L'Hopital, but I don't want you to do this by L'Hopital because I want you to learn how to apply expansion. Because once you apply the expansion, then only you'll be able to feel confidence in yourself that okay ma'am, series expansion I'll remember and I'll apply. Okay? ठीक है. चलो. E raised to power x minus 1 minus x upon 3x square 0 by 0 form. Let me just start applying. E raised to power x is what? 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Okay? Right? Minus 1 minus x upon 3x square. Alright? 1 plus x gone. Right? 1 plus x gone. Remember, x is tending towards 0, right? X square is gone. So, I'll be left with what? 1 by 2 factors, so 1 by 6 plus x square and x cube. So, x by 3 factorial into 3. So, this will become 0 and rest all the terms will become 0. So, the answer will be 1 by 6. Very good. Luxury Hitler 1 by 6. Yes, 2025 students definitely can attend the session 100%. It is written on the title only, JEE 2024/2025. One by six, Vijay Lakshmi, yes, Vaishnavi, perfect. All right. Next, tan x. I told you. Tan x. Let's see how many of you remember expansion of tan x. But don't just apply expansion of tan x. First simplify. This would be tan x plus x. Right? and tan x minus x. Okay, and here you will have x square tan, so here it will be tan square x. For tan square x, you will have x square, okay, and here x and here x cube. Is that correct? Did you understand? Did you understand what I did? So I had 1x square. I kept 1x over here, okay, and 1x over here. But I needed 1x square over here, so 2x over here, right? What is the expansion of tan x? X plus x cube by 3. X so you know, x cube by 3 plus 2x raised to power 5 by 15. Okay, let's just apply it. See, tan x by x, limit tan x by x is 1 plus x by x is also 1. This is sorted. Now apply expansion of tan x over here. So this will be x plus x cube by 3 plus 2 by 15 x raised to power 5 all the way up to infinity minus x. This will become 1 and this will become x cube, right? So this is 2, x cancel, x cube cancel, only 1 by 3 plus all the zeros will be left out. So it will be 2 by 3 will be the correct answer. 2 by 3 will be the correct answer. Yes? 2 by 3, 2 by 3, 2 by 3 all set. Alright, so 0 by 0, I guess we have given enough time to 0 by 0, but trust me, we have 7 forms, we will study all 7 forms, but I have given majority of time to 0 by 0 and infinity by infinity. One more explain, ma'am, okay. One more time, let me just explain this. One more time, so tan square x, so tan x plus x, tan x minus x, correct? Alright, upon. This is tan square x. So here x and here x. I have distributed x. Till here it is clear. Is it clear till here? Tan x plus x, tan x minus x. This x square I have distributed 1x here, 1x here. This is my tan square x. I need 1x square over here. So I need 1x square over here as well. Let's see that this x square will be utilized by this bracket or this bracket. Let's see what happens to this x square. Will it go towards this or this? Right, so first of all understand this. Tan x by x. So tan x by x plus x by x is 1. Limit x tend to 0. This is 1 plus 1. So this is actually sorted. This whole will get combined. Now tan x expansion of tan x is x plus x cube by 3 and so on up to infinity minus x upon x cube, right? And this will anyway become 1 because tan x by x is 1, okay? Right? Now this is what? This is 1. So 1 plus 1 is 2. X cancel, x cube cancel. So this will become into 1 by 3. So this is coming out as 2 by 3. This is coming out as 2 by 3. Yes? Got it? Alright. Now quickly infinity by infinity form. Right? 50%, more than 50% limits we have covered because the major the chunk is nothing but 0 by 0 and infinity by infinity form. Okay? Don't worry. We'll finish it on time. X plus 1 upon x plus 2. Okay. So the moment you see infinity by infinity form, listen to me carefully now. All the attention, I want your maximum attention over here. I want your max. Yes, you can apply L'Hopital. But infinity by infinity, what you have to do is take out maximum power common from the bracket. So what do you get? You get take common x. So you get 1 upon 1 plus x. Take x common again, 1 upon 2 by x. X cancel, right? The moment you plug in infinity, this will become 0. This will become 0. So yes, you are correct, my dear students. That 1 is the correct answer. You are absolutely correct that 1 is the correct answer. Okay. Another question. Quickly in the chat box, answer for this particular question. Another question. The answer would be what? 1 by 3, 1 by 3, 1 by 3. Okay. 1 by 3. Shiva Kumari, Vijay Lakshmi. What about others? 1 by 3. Are we having more 1 by 3? 1 by 3, 1 by 3, infinity. All right. So the answer is, okay, I am getting 3 different answers for this particular question. 1 by 3, infinity, 0. 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 Okay, all right. So first of all, realize one thing. So what I told you, okay, let me just do it with multiple methods, okay. The very first method, what I told you, the moment you see infinity by infinity form, what you should do is take out maximum power common. So the moment I take x cube common, maximum power is x cube, right? The moment I take x cube common from here, what I'll be getting is 1 by x minus 4 by x square plus 5 by x cube whole upon. The moment you take x cube common, 3 by x cube is common, right? Minus 1 plus 2 by x cube. So this will become 0, this will become 0, this will become 0. X cube cancel. This will become 0, this will become 0. So 0 upon minus 1, it is coming out as 0. It was a googly question actually. By looking at the question, some students may get yes, because the numerator degree is smaller than denominator's degree. Degree which you are seeing in numerator is 2 and degree which you are seeing in denominator is 3. So when the degree in numerator is smaller and in the denominator is bigger, right, then the answer is 0. So in infinity by infinity, note it down. There are 3 types of questions. First is degree of numerator is equal to degree of denominator. In that particular case, you just write the coefficient of highest power. So coefficient of highest power is the correct answer. This is your ninja technique. Please write ninja technique. Please write this ninja technique. The moment you get infinity by infinity, the very first thing you are going to check is, okay, is degree of numerator and denominator are same? In this particular, this is same. So your answer would be what? 1 by 1. The coefficient of highest degree upon the coefficient of highest degree, right? Whenever you see degree of numerator and denominator are equal. Now the moment you see degree of numerator is greater than degree of denominator, your answer would be infinite. And the moment you see degree of denominator is greater than degree of numerator. Here denominator is greater, just like this question, degree of denominator is greater, then your answer would be what? 0. Right? Right? So I will give you 3 questions. 2x plus 3 upon 3x plus 4. Of course, limit is x tend to infinity. What would be the answer? Limit x tend to infinity 2x plus 3 upon 3x plus 4. What would be the answer? 2x plus 3 upon 3x plus 4. So we have observed, okay, degree of numerator and denominator are equal in this particular case. So coefficient of highest power, that means 2 by 3 will be the correct answer. Okay. Now the second question. Limit x tend to infinity 2x plus 5, 2x square plus 5 upon 3x plus 5. What would be the answer? Tell me. Tell me. Shortcut. Infinity by infinity form. Numerator is greater than denominator. That means the value would be infinite. The limit, the value of limit is infinite, or we can say does not exist, because infinite does not exist. Third is limit x tend to infinity 3x plus 5 this time upon 2x square plus 5. 2x square plus 5. In this particular case, what is happening? Degree of numerator is smaller than degree of denominator. 2x square plus 5. So this value would be what? 0. Got your point? Concept clear? Yes? Alright. Now let's just start solving these two questions quickly. Speed mathematics. Fatafat se. I need answer in a few seconds. These two questions. In this particular case, go by the method. Go by the method. In the very first place, what is the basics? Don't forget the basics. No matter how much shortcuts you know, don't forget the basics. So the very first basic is the moment you see infinity by infinity form, take out the highest power common. Take out the highest power common. In both the questions, please follow the basics. Please follow the basics. Take out the highest power common. Do realize that this is extend to minus infinity. All right. I guess only one student is giving me, okay. Shiva is also giving me, okay. I'm getting a few correct answers as well. Let's just start. If I take highest power common, so here highest power is x and here highest power is x square. If I take x square common, since x square is inside the square root, it will become x, or rather it will become mod x. So limit x tending towards minus infinity, if I take x square common from this, it will become mod x square root of 3 plus 2 upon x square whole upon 1 minus 2 by x, because I am taking x common from here as well. So what did I do? From the numerator I took x common, it will become mod x, and from the denominator I took x common, it is very basic, just x common, right? Now x is minus infinity. Realize the fact that your x is minus infinity. When your x is negative, x mod x is equals to minus x when your x is negative. You know this, right? You know the definition. Your mod x will become minus x, x will remain x. Mod x will become minus x when you know that your x is negative. Now the moment, so this will get cancelled, x will get cancelled. The moment you plug in minus infinity, so this will become 2 by infinity 0, 2 by infinity this also 0, so this will become root 3. So minus root 3 is the correct answer. This is a googly question for you people. Googly question for you people. Perfect, cool. Let's move on to the next question now. What is this? X tending to infinity. Now take out the highest power common. Now this time x is positive. This time x is positive, so we don't need to worry about mod x because mod x will get open with a positive sign. Alright, cool. But what I need to do is I need to take out common. What common? The highest power. Now which one is bigger? X or sin x? Which one is bigger? X or sin x? Which one is greater? X or sin x? Realize one thing, when x is infinity, so this is infinity. But sign of infinity will every time lie between -1 and 1. Are you getting my point? This is tending towards infinity and sine infinity is lying between -1 and 1. That means what? Which one is bigger? X is bigger. So what should I take common? X should be the common in the numerator and in the denominator. So 1 plus sin x by x upon 1 minus cos square by x. Square root is there, limit x tend to infinity is there, right? The moment you plug in infinity, sin infinity by infinity, this will become 0 because this is finite by infinity. Also, this is also finite by infinity. This is also 0. So, this will become 1. 1 is your correct answer for this particular question. Yes, luxury Hitler. Absolutely right. Absolutely perfect. Very nice. Very good. Awesome. Awesome. Perfect. Next, last two questions. Last two questions, same infinity by infinity form. Then we are done for the infinity by infinity form. Quickly just solve and give me the answer. You have only 2 minutes to solve this question. Only 2 minutes. Only 2 minutes. Alright, so as you can see, where n is tending towards infinity, what would be the biggest number? 3, 4, 2, 5. Obviously, 5 raised to power n is the biggest number of all. Are you getting my point? 5 raised to power n would be the biggest of all. 5 raised to power n common from numerator and denominator. Once you do that, you will get 3 by 5 raised to power n minus 4 by 5 raised to power n upon 2 by 5 raised to power n minus 5 by 5 raised to power n. Alright, this is cancel and limit n tend to infinity. Yes? Yes. 3 by 5 raised to power n, 4 by 5 raised to power n, 2 by 5. Now tell me, 3 by 5 is a fraction. N is your infinity. Fraction raised to power infinity is 0. 4 by 5 is also a fraction. Fraction raised to power infinity is 0. 2 by 5 is also a fraction. Fraction raised to power infinity is again 0, and this is so 0 minus 0 upon 0. This is minus 1. So what will become is nothing but 0. 0 is your answer. Not 1 by 3. No 1 by 3. Class lecture and DPP is enough for JEE Main. Class lecture plus a lot and lots of PYQs are enough for JEE Main, है ना? So you have to solve as many PYQs as possible. So I would say start from 2023, 2022. These two are must. Then once you are done with 2023 and 2022, go for 2021 as well. Okay, 2021. And remember, in 2021, there were multiple papers, multiple questions. So 2021 carries a huge chunk of problems. And don't worry, like tomorrow we have a PYQ marathon. You all know this, right? starting from 11 o'clock in the morning. We have a PYQ marathon. I will be taking LCD, limits, continuity and differentiability problems only, right? Okay. Now this one, this question, this is very simple. Sine raised to power 2x upon 2 raised to power x, limit x tend to infinity. Check the form, always check the form. Sine 2 raised to power infinity, so this is nothing but sine infinity which lies between -1 and 1. That means this is a finite number upon 2 raised to power infinity which tend towards infinity. So this is finite upon infinity, this will become 0. This will become 0. Alright, infinity by infinity, done and dusted, 0 by 0, done and dusted. All the methods, right? Now we are moving towards infinity minus infinity form. And actually, if I talk about all 7 forms, so 0 by 0 and infinity by infinity is king of all forms, I have already told you, right? But after that, there are 2 forms which are my favorite forms. One is infinity minus infinity and another one which is again my favorite, very favorite, most favorite, 1 raised to power infinity. These 2 are my favorite. If I am saying my favorite, it is examiner's favorite as well. Alright. Infinity minus infinity. How do you tackle infinity minus infinity? So I am going to give you 2 methods for this particular question. Okay, for this particular. First of all, just realize one thing, identify the form of this particular question. So infinity, the moment you plug in infinity over here, this will become infinity and this is also become infinity. So this is an infinity by infinity form. How do you solve infinity by infinity form? So let me just tell you, all those form except 0 by 0 and infinity by infinity. So all the rest 5 forms are convertible form. I am going to convert this infinity by infinity into either 0 by 0 or infinity by infinity form. Are you realizing what I am trying to say? I want you to understand this very, very nicely. I am going to convert all the rest of the forms in these 2 forms, either 0 by 0 or infinity by infinity. Can I do that? Once I do that, then I know how to solve this. Are you getting my point? If I convert this particular form to infinity by infinity, will you be able to solve it? Yes? Yes? I need yes in the chat box. Are you able to understand the thing? Yeah. How many? This program is for 40 days, important chapter. क्या बोल रहे हो? चलो, let me just solve this question. I'll show you what I'm trying to say. So to solve this question, I have 2 different methods. Yes. First is rationalize. The moment you start rationalizing, so you have to multiply x square minus 8x plus x upon x square minus 8x plus x. Rationalization. Okay. Now, a minus b, a plus b. A minus b, a plus b. So it will become a square minus b square. Correct? A square, it will be free from root, and this is b square. Whole upon square root of x square minus 8x plus x, limit x tend to infinity. Right? So x square cancel. Now can anyone tell me what is the form? Can anyone check the form in this particular step? Can anyone tell me what is the form right now? The moment I plug in infinity over here, it is infinity. The numerator is infinity. What about the denominator? Infinity plus infinity, infinity. So I have converted infinity minus infinity form into infinity by infinity form. Now what I am going to do is every other form I am going to convert in either 0 by 0 or infinity by infinity, two basic forms. Are you getting my point? Are you getting my point? Now just solve it. Infinity by infinity, you know, take out x common. The moment you take x common, here it will be minus 8. The moment you take x common from here, it will be 1 minus 8 by, so 1 minus 8 by x ka root and plus 1. Okay, x common from everywhere. Right, the moment you plug in x tend to infinity, what would you get? This will be 0. So this will become minus 8 upon 1 plus 1. So this will be minus 8 by 2 minus 4. Have a look. Note it down. This is method number 1. This is method number 1. Method number 1. Note it down. Method number 1. Shall I erase this? Shall I erase this? Shall I erase this? Method number 2. Remember, I was writing binomial expansion. Remember, 1 plus x raised to power n is approximately equal to 1 plus nx, I told you. But remember, here x is very, very smaller quantity. Remember this? I called it love. I love binomial expansion. Now, please pay attention to this method number 2, because once I teach you method number 2, I have a problem from JEE Main 2021. Similar problem from JEE Main 2021, and trust me, it is, I would not say it is an easy problem. I would not at all say. But once you understand this method, I am damn sure that you will be able to crack that JEE Main 2021 problem, which I am going to give you right after this method. Okay. So 2 to 3 minutes I will be solving this method 2, and I need your maximum attention. Okay. Alright. How to solve it? Realize one thing. First of all, what I am going to do is, I am going to apply binomial expansion in this. And this is my target expression. Here I am going to apply binomial expansion, right? X square minus 8x raised to power half minus x is my expression. Limit x tend to infinity, right? Okay. Now how will I apply binomial expansion in this? Because in binomial expansion I need a 1 over here, and I need a quantity which is very, very extremely small. So 1 plus extremely small raised to power something. 1 plus extremely small raised to power something. I am going to create it over here. Take x square common from here and take x common from here. The moment I take x common from here, so x square if I take common, here square root is here, it will become x. Yes? Yes or no? The moment x square is gone, it will become 1 minus 8 by x raised to power half. Since I have taken x common, this will become 1. Why am I doing that? Because I want to make this x square as 1, right? Because I want to apply binomial expansion. So 1 plus some small quantity. The moment you put x infinity, this will automatically become a small quantity. Yes? So 1 plus some smallest quantity raised to power something is what I wanted and what I got. Only this method, only this step is difficult, or you can say a little bit tricky. Post that, in 5 seconds you will get answer. In 5 seconds. Now just apply binomial expansion and then you are done. One step, just one step. Let's apply binomial expansion. X is outside. So 1 plus, so what is happening? This n is coming in front of this x, right? This n is coming in front of this x. Let me just write 1 minus, this half will come in front, 1 by 2 into 8 by x. Minus 1 is already there, brackets opened, and 1 say 1, it is cancelled. X is also cancelled. Minus 4 is the correct answer. Minus 4 is the correct answer. Only this step you have to understand, and rest binomial expansion and you are done. Please look at it. Let me know. I will explain you one more time, because after that I am going to give you one question, similar question which happened to come in 2021. Right? Yes? Understood? Understood? Shall I give you the problem? Shall I reveal the problem? Ninja, promise that you will attempt that question wholeheartedly and give me the correct answer. Okay? Similar type of question, JEE Main 2021, and this is the problem. A little hint. Shall I give you little hint? No? C or D? No, that's not. You are not playing KBC with me. I am not Amitabh Bachchan, and I don't have that powers, that computer G. Can you please disappear 2 answers? Ding. I'll reveal the next chapter by the end of the session. Okay, Luxury Hitler is saying option B is correct. Okay. So, again, x square minus x plus 1 raised to power half minus ax. Okay. Limit x tend to infinity. Again, same type of question, right? Now, you have to take something common. What you need to take common? X square should be common. The moment you take x square out of this bracket, the power is half. X will come out as common. It will become 1 minus 1 by x plus 1 by x square raised to power half minus a, because this x is also gone now. This x is also gone. This is the hint. Now what you need to do? Again, so 1 plus x raised to power n is approximately 1 plus nx. This is the binomial expansion I was talking about. This is the binomial expansion I am talking about. Alright. So this half will come in the front. This half will come in, the x will stay outside, and 1. So half will come over here. So minus 1 by 2x plus 1 by 2x square. That's it. I have multiplied half in these two quantities. Here my x is nothing but minus 1 by x plus 1 by x square is my x. So I need to multiply half over here. Okay, and then minus a is here. That's it. That's it. Okay, limit x tend to infinity. Limit x tend to infinity. What is my expression becoming? So limit x tending to infinity, right? Now multiply x. The moment you multiply x, you get x times 1 minus a. Okay. The moment you multiply, you get minus 1 by 2. And the moment you multiply, you get 1 by 2x. And so on. This is equals to b. That's what you get. Okay. Now, yahan tak I guess everybody is aware that we have come till here. Now realize one thing. In the question itself, who all are stuck over here, please listen to me carefully. In the question itself, it is given that this limit is equal to b. That means this limit will exist. This limit should exist. In the question itself, it is given that b is a finite quantity. That means this limit will exist. For this limit to exist, this term, that means the moment you plug in infinity in place of x, this whole expression will go towards infinity. And this left hand side will become infinity, which we don't want. We don't want this left hand side to become infinity. Do you want it? No. Why? Because in the question itself, it is written that this expression is equals to some b, which is some finite quantity. So that means we have to make this 0. We have to make a is equals to 1 so that this infinite quantity will get vanished. Are you understanding? Are you getting my point? This has to die. This has to die. Why? Because if it doesn't die, then what will happen? This expression will become infinite. This whole limit will become infinite, and this infinite is equals to b. b will become an infinite quantity, which we don't want. So that's why 1 is equals to a, so that this infinity is gone. Let's just remove this infinity. Okay. And the moment you plug in infinity over here, 1 by infinity will become 0 automatically. So clearly, this is also 0, this is also 0. Clearly, b is coming out as minus half, and option B, is absolutely right. Now, absorb it, give it 10-15 seconds, absorb it, understand it. I am standing right here. I will explain it to you one more time if you are having any trouble in this. Clear? I am right here. Just have a look. All right. So what till now? Fourth step one more time. Yes. Fourth step क्या बोल रहे हो तुम? मैं तुम्हें सब बता रही हूँ. रुक जाओ. Just wait a minute. है ना? So what we have done is we have understood that okay, I need to apply binomial theorem in binomial expansion in this. So x square minus x plus 1 raised to power half minus ax. Okay, right? Limit x tend to infinity. I am not writing again and again. Okay. Now x square, if I take x square common, the power is half. X will come out 1 minus 1 by x plus 1 by x square raised to power half minus a. I have just taken x common. Alright. Now just apply binomial expansion. Binomial expansion, what does it say? That 1 plus smallest quantity raised to power half, this half will come in front. So half will get multiplied over these two terms. X is outside and inside we have 1 minus 1 by 2x plus 1 by 2x square minus a. Okay. Now we know that this quantity should be a finite quantity. This quantity is a finite quantity. So x multiply x. So x 1 minus a minus 1 by 2. देखो ना x cancel plus 1 by 2x is equals to b, limit x tend to infinity. Okay. The moment I start putting infinity in this, I realize, okay, the moment I put infinity, this will become 0. Alright, sorted. What about this? This will become infinite. So, infinite minus half is equals to b. Infinite minus half is equals to b. Right? But this is not possible. If this is possible, if this is like, if you make it happen, then b will become infinite, which is not possible. B cannot be infinite. So what you will do? This infinite has to die. This infinite has to die. This x has to die. How will it happen? When you make a is equals to 1. When you put a is equals to 1, this will become 0 and 0 into infinity will be exact 0. Exact 0 infinity will be what? 0. So this will be gone. B would be, so this will be gone. B is minus half. A is equals to 1 and option B is absolutely right. Alright, okay, I got your point. Gothram Raj is asking, ma'am, 0 multiply infinity to indeterminate hota hai. Ma'am, 0 multiply infinity is indeterminate, right? So why are you like 0 multiply infinity? So you to writing 0. No, you are getting it all wrong. So yes, 0 multiply infinity is indeterminate, but exact 0 multiply anything is 0. Exact 0. Here a is equals to 1. That means this is exact 0, not tending towards 0, right? That's why it is 0. There is a difference. Okay. Alright. 0 multiply infinity. So this 0 is nothing but tending towards 0 into infinity. Right? Okay. Okay. Gothram Raj, very good question. So actually you must have seen 1 raised to power infinity एक indeterminate form होता है, right? But this 1 over here is tending towards 1 raised to power infinity. This confusion happens to many good students, topper students as well. And exact 1, tell me, exact 1 raised to power infinity, what does that mean? Exact 1 raised to power infinity. Exact 1, that means 1. If I multiply 1,000 crore infinite times, I will get 1 only. 1 multiply crore times 1,000 times, I will get 1 only. Right? So, how come फिर 1 raised to power infinity is indeterminate form? Because in 1 raised to power infinity is 1 is not exact 1. It is tending towards 1 raised to power infinity. Alright. Okay. Little bit clear, Gothram? Little bit clear? Little? Okay. Alright. So this is the question. Now you will be very happy. You'll be very happy. Seeing this question, the way I solve it, you will be very happy. So can you please tell me what is the form? This is infinity and this is what? Sine 1 by infinity, sine 0. So sine 0 is 0. Sine 0 is 0. Right? Zero multiply infinity. Now I'm gonna make this as, alright, 0 by 0 form. I'll convert this into 0 by 0 form. I'll convert this into 0 by 0 form. How? Let me just tell you. 0 multiply infinity, right? Now if this is an infinity, can I write it as 1 by 0? Can I do this? Can I write 1 by 0 in place of infinity? So it will become 0 by 0. Yes? Yes? Okay. Alright. So sine 1 by x upon 1 by x, limit x tend to infinity. Can you just tell me what is this form? What is this form? Bilkul 100%, absolutely Vijay Lakshmi. Sine 1 by x upon 1 by x. What is this form? So it is sine 0 by 0. So this is 0 by 0 form. Can you see that? In front of you, right here I have converted 0 into infinity form into 0 by 0, or you can either convert it into infinity by infinity as well. No, Divakar, this is 0 by 0. The moment you put infinity, it will become 0. So this is 0 and this is also 0. So sine 0 by same 0 is coming out as 1. 1 is the correct answer. Are you getting my point? That's why from the beginning of this chapter, what I'm trying to say is focus on 0 by 0 and infinity by infinity. All the rest 5 forms will be convertible forms. Will be eventually solved by 0 by 0 or infinity by infinity method only. Okay, JEE Main 2018. Here we have a question. Okay, I'll give you 2 minutes to solve this question. 2 minutes to solve this question. You're almost towards the end of the limits. Once we finish limits, we'll take 5 to 10 minutes break definitely. Don't worry about that. I'll give you a break. Okay? Okay. After 1 minute, I'll give you a hint. After 1 minute, I'll give you a hint. Shall I do it? Tick, tock, tick, tock, tick, tock, tick, tock. Okay, hint. Yes, I'll give you 15 minutes break. We are towards the end of the limits. Once we finish limit, then I'll also have my dinner. You'll also have your dinner. Okay? Alright. So hint. Hint is your GIF of x will be nothing but x minus fractional part of x. Use this formula. Convert each and every GIF into this. 100% you will get the solution now. This is the game changer. This is definitely a game changer. Vijay Lakshmi is saying option A. Alright, some are saying A, some are saying B. Let's see. Apply the hint. 1 more minute. 1 more minute. Chalo, let's solve. Let's solve. Okay, maybe this hint worked for some people. I can see correct answers in the chat box. So let's just apply that hint. Limit x tend to 0 plus x is here. Okay, so this will become what? I already told you GIF of x is nothing but x minus fractional part of x. Just apply this. So GIF of 1 by x will be 1 by x minus fractional part of 1 by x plus 2 by x minus fractional part of 2 by x, right? Plus 3 by x minus 3 by x ka fractional part, and so on. 15 by x minus fractional part of 15 by x. Correct? Now collect all these terms, 1 by x, 2 by x. Let us collect and put it together. If I do that, I'll get x, 1 by x plus 2 by x and all the way up to 15 by x. Right? Inside one bracket, and x times another bracket would be fractional part of 1 by x. fractional part of 2 by x, fractional part of 3 by x, and so on, fractional part of 15 by x. Can you see? This x will go inside, it will become 1 plus 2 plus 3 and all the way up to 15. This is sorted. Here limit x is tending towards 0 plus minus. Now realize one thing, if x is tending towards 0 plus, so 1 by infinity, 2 by infinity, 3 by infinity, but here can you see this is a fractional part. This is a fractional part. This value lies between 0 and 1. This is very small value. This is also very small value, very small value, very small value, very small value multiplied by 0. So 0 multiply very small value is 0. So this is gone. This is boom. This is gone. Very simple, looks scary. Yes. So 1 to 15, sum of first 15 natural numbers. You know the formula, right? 15 into 16 by 2. 120 is the correct answer, option A. Did my hint work? Did my hint work? Yes or no in the chat box. Did ninja trick worked? Did ninja trick work? Yes. All right. And this is, I already told you, my favorite form. My favorite form. Quickly, let's finish. So, till now we have covered 0 by 0, infinity by infinity, infinity minus infinity, and then 0 multiply infinity as well. So, we have covered 4 forms. Okay, 3 forms are still left. We'll finish all these 3 forms very quickly. 1 raised to power infinity form, very important, very different actually, different from what we all have studied. So, that's why this need a little bit attention, more attention over here. Okay, right. So let's say you have a function 1 raised to power infinity f of x raised to power g of x. Right, this is your question. Limit x tend to some quantity a. Right, this is your question. Right, and here this is your base fx. Fx is tending towards 1 when your x is tending towards a. This tend towards 1. This is your 1 and this is your infinity. So gx tend towards where? Infinity, when x tend towards a. How do you solve it? So there is a formula for it. There is a formula for it. What is the formula? What is the formula? Very simple. E raised to power limit x tend to a. E raised to power limit, how to solve it? E raised to power limit x tend to a, bring the power in front, bring the power in front, okay, bring the power gx in front and subtract 1 from this base f of x. That's it. That's it. That's it. You have to remember this. Okay. I'll just give you a demo. I'll give you a demo, you will understand. Anyone remember this standard limit? This was the standard limit, right? This was the standard limit. No, Vaishnavi, you forgot. E raised to power. Vaishnavi, you forgot. Don't forget that E. E raised to power fx minus 1 into gx. Okay? Right. Anyone remember this limit, the standard limit? I asked you to remember. Yes, luxury, Hitler. E. 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 The correct answer of this is E. You all should remember the standard limit, right? Now, how do we solve it? First of all, realize one thing, that this is of the form 1 raised to power infinity. The moment you plug in x equal to 0, you will get 1 raised to power infinity. 1 raised to power infinity, right? How do you solve 1 raised to power infinity? How do you solve 1 raised to power infinity? We have a formula. E raised to power limit x tend to 0. Bring that power in front. 1 by x. Subtract 1 from this. So 1 plus x minus 1. Simple. Done. X. Okay. 1 gone. X gone. So you will be left with e raised to power 1. Just tell me one thing, whether it is clear or not. Yes? Yes, one more time. One more. One more. Okay, let's just solve this one. Let's just solve first of all this one. So I told you e raised to power, this power will come in front. So 1 by x multiply, subtract 1 from the base. That's it. 1 cancel. So e raised to power x upon x, e raised to power 1. One more question, yes. So e raised to power, this power will come in front. Okay. Alright, bracket, subtract 1 from this. So 1 plus 1 by x minus 1. 1 cancel. E raised to power x upon x get cancelled. E raised to power 1. Getting? Little? Getting it? Getting the hang of it? How do you do that? Acha, are you having problem in remembering this formula or applying this formula? Problem in remembering or applying this formula? Okay, try this question then. JEE Main 2020. Try this question. Formula get it in my mind. Your English is also get it in my mind. JEE Main 2020. Alright, let's just check the form of this particular question. Always check form first. Okay, the moment I plug in x tend to 0, I'll get what? 2 upon 2, 1 raised to power 0 square. So 1 raised to power infinity is the form. 1 raised to power infinity is the form. 1 raised to power infinity is the form, right? Form check, form check, form check. Yes, form check. Yes, 𝐸𝐴, I know Hindi. Better than English, I know Hindi. Okay, alright. Chalo. So this is 1 raised to power infinity. How you solve it? E raised to power. Power will come in front. So 1 by x square. Alright. E raised to power. Power will come in front. Bracket mein what will happen? Subtract 1 from this base. Subtract 1 from this base. Limit x tend to 0. Yes? Now just solve it. This will become 0 by 0 form. Just solve it. Okay? So, e raised to power limit x tend to 0. So, this is it. Okay? Now subtract. So, 1 by x square, 3x square. Take LCM. Take LCM. Take LCM. Take LCM. Two and 2 are getting cancelled, right? So, e raised to power limit x tend to 0, 3 minus 7. So, minus 4x square upon x square is already there and 7x square plus 2. X square gone. The moment you plug in x equal to 0, what will you get? E raised to power minus 4 upon 0 plus 2. 0 plus 2. So, e raised to power minus 2. This is nothing but 1 by e square. Option A. Option A. Prasanna, why C? Minus 4 by 2 e raised to power minus 2. Why C? Why option C? Don't do that. Don't make silly mistakes. Any doubt, any confusion? All right, all right, all right. Last two forms. Last two forms. Last two forms. 0 raised to power 0, infinity raised to power 0. 0 raised to power 0, infinity raised to power 0. What is this form? Both are having same technique. Both are having same technique. 0 raised to power 0, infinity raised to power 0. Both are having same technique. This is the last. This is the last 5 minutes. I'll give you definitely a break. Please see, next is what? One question and then continuity. Yes, luxury Hitler, very good, very nice. The moment you see 0 by 0 form or infinity by infinity form, take logarithm. That's it, done. That's it. Okay, limit x raised to power x, x tending to 0 plus, right? So what will you do? Just put this equal to L. And what I told you, take log. Take log. Take logarithm on both the sides. So log L is equals to limit of x tend to 0 plus log of x raised to power x. The moment you see 0 raised to power 0 form or infinity raised to power 0 form, take logarithm on both the sides. Okay, alright. This x, use the property. This x will come in front. So log L is equal to limit x tend to 0 plus x log x. Check the form, check the form, check the form. Check the form, form check. Form check. Form check, form check. Okay, the moment you plug in 0, you will get 0 into log 0 plus. So this is 0 multiply infinity form. Did you notice? Did you notice? We are actually, by taking log, what we are doing? We are converting the form. We are converting into our basic form 0 by 0. Okay? Alright? Check, check, check. Done, done, done. X log x. Alright, so this will become what? Okay. So limit x tend to 0 plus log x upon 1 by x. Check the form, check the form, check the form. Form check, form check, form check. Form check, form check, again form check, form check. Okay, log 0 is infinity and 1 by 0 is infinity, infinity by infinity form. Your favorite method. In the chat box, what would be the next step? Your favorite method. Your favorite method. In the chat box, L'Hopital. Apply L'Hopital. Now is the time. In the last question, apply L'Hopital. Till the very end, I never applied L'Hopital. Now I am going to apply the L'Hopital proudly actually. So just apply L'Hopital. What will you get? Log x ka derivative 1 by x. 1 by x ka derivative 1 minus 1 by x square. Limit x tend to 0 plus minus x. So this will become 0. 0, 0. What would be the final answer? What would be the final answer? Luxury Hitler. What would be the final answer? What is the final answer? Gotram Raj. What is the final answer? I am asking you the final answer. Your final answer will make me understand that who all are listening to me very, very carefully. Luxury Hitler, incorrect. Divakar, incorrect. Gotram Raj, incorrect. 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 What I am looking for is L. What I am getting over here is log L. Log L. log L is coming out as 0. That means L would be 1. Silly mistake. Spotted. Do you want me to explain one more time? हाँ, luxury Hitler, got your point. Guthram, okay. Maybe, okay. Accepted. But many students were saying 0, right? Alright. Okay, so this was the last question for the limit, not for the day, because we have 50% of the chapter left, and this is the problem I want you to solve. I'll leave you with this problem after the break. Okay, so how much time break do you want? 10 minutes? You want 10-minute break? 10-minute break, 15-minute break, quickly. 10-minute, 15-minute. I'll resume it from here. JEE Advanced 2012 question, and this can fifteen, 20 minutes. Okay, I'll see you at 9:25. Audible, visible? All right. All set? Recharged? Yes. I am also back. All right. The break was given to make sure that you are recharged once again with same josh, same energy. We are starting, okay, last question of the limits. Then we'll move towards the new topic, new chapter you can call it, continuity. Perfect. Let's begin. Okay, I can see I was seeing your comments. 2-3 people have already done this question and calculated the value of A and B. So quickly let me just give you the solution now. All right. This was the question, limit x tend to infinity. This is infinity by infinity and this limit is equal to 4. What we need to do is we need to take the LCM out of it, okay? The moment we take LCM, you get x square plus x plus 1 minus ax plus b and x plus 1 whole upon x plus 1 limit x tend to infinity. All right? Yes. Hi Anjita, how are you? Welcome to the session. Welcome back to the session. Chalo, let's now collect all the terms. Let's now multiply this, collect all the term related to x square, then x and everything, right? So x square plus x plus 1 minus ax square minus ax plus bx, sorry, minus bx minus bx minus b whole upon x plus 1. Collect the terms now. X square 1 minus a x square, alright, and then these three terms together, 1 minus a minus b, correct, times x, and we have 1 minus b whole upon x plus 1 limit x tend to infinity. Again, this is equal to what? 4, right? This is infinity by infinity, right? Now realize one thing, that this x square, that means this will become infinity square. This particular term will make the whole expression towards infinity, will tend the whole expression towards infinity. Yes or no? This particular x square into 1 minus a will make sure that this expression will tend towards infinity, which we don't want. So this has to die, this has to die, this has to vanish. So a should be equal to 1 so that this will become 0. So here we have a is equal to 1. The moment we make a is equals to 1, this will become 0. What will this become? 1 minus a minus b times x plus 1 minus b whole upon x plus 1 limit x tend to infinity. Again, infinity by infinity form, where the degree of denominator and degree of numerator are equal. So the answer would be 1 minus a minus b is equal to 4. And we have already said that a is equals to 1. So 1 minus a minus b is equals to 4. Absolutely. So those students who were writing b is equals to minus 4 and a is equals to 1, thumbs up. Absolutely correct. B is not 0. No, B is not 0. No. Raju, you are not writing, you're not solving it correct. This is the correct solution. B is minus 4. No, B is not minus 1. B is minus 4. Sorted? Okay, next chapter. Continuity it is. Finally. Limits. Killed it. Done, dusted. Okay, now it's up to you who are going to solve as many PYQs as possible. And by the way, tomorrow 11 o'clock, 11 a.m. in the morning, 11 a.m. in the morning, you all know, we have a PYQ session. Shreyas sir will be starting the session at 11 in the morning sharp. Post that, Namrata Ma'am will be taking PYQs, and the last I will be solving limits, continuity and differentiability, same topics PYQs. Right? Perfect. So make sure you come on time. Make sure you attend the session till the very end, because in the end I'll be there. Okay? And in the beginning Shreyas sir will be there. And Namrata Ma'am will take the session in the middle, 1 o'clock. Physics, chemistry, mathematics. Perfect. Done. Okay. Noted. Took the screenshot, pasted in your head. Clear. Let's go ahead. Continuity of a function. Alright. Very simple. Very fun definition. Very simple. Need lengthy problems for tomorrow's session. Acha, luxury Hitler, you want lengthy problems. Okay. Alright. Let's see. Continuity of a function. So, continuity of function is very easy. Continuity of function, to understand continuity, we just need to know that there in the graph, by looking at the graph, the definition says that there should not be any jump. There should not be any jump while making the graph of the function. If there is any jump or any break, you can say, in the graph, then that function is discontinuous. No jump, no break. No jump, no break. That means you should not lift your pen while drawing the graph of a continuous function. If you need to lift the pen to draw the graph, then that function would be what? A discontinuous function. For example, this. If I plot the graph of this function, you can see, okay, you can see that I need not to lift the pen. Do I need to lift the pen? No. So this is a continuous function, no break, no jump. What about this graph? What about this graph? So if I start drawing this graph, I can clearly see that here there is a gap. I need to lift the pen. At point A we have this and this. So this is a discontinuous because I can see a break or jump. So this is a discontinuous function. Yes? Getting it? Perfect. Got it? Now you are the one who is going to answer whether this function is continuous or not. Continuous or not? In the chat box. Continuous or not? Continuous or discontinuous? Tell me in the chat box. Continuous or discontinuous? Continuous or discontinuous in the chat box. Quickly reply. Continuous or not? No, discontinuous. So this is a discontinuous graph clearly. Why? Because the moment I start plotting the graph, I can see there is a jump, there is a break. That's why this function is discontinuous. What about this? What about this? What about this? Is this a continuous function or discontinuous function? Continuous or discontinuous? Continuous or discontinuous? So again, let me just plot the graph. I can see till here. Okay, it's smooth, but I need to lift the pen. And then, so this is also discontinuous. Discontinuous function, discontinuous function. Okay. All right. So by looking at the graph, by looking at the graphical definition, we understood what is continuity, what is discontinuity. But mathematically, if I want to express the continuity, that simply means, mathematically simply means that if we are saying that any function is continuous at any given point, that means what we are saying is that limit of that function at x tend to a minus, that is your left hand limit. Your left hand limit should be equal to your right hand limit, should be equal to value of the function at that point. If it is the case, then we can call it the function as a continuous function at x equal to a. This is the definition. What is the definition? The left hand limit at that point should be equal to right hand limit at that point, should be equal to value of the function at that point, and if this particular equation holds true, then only we can say that the function is a continuous function at point x equal to a. We are talking about continuity at a point. In here, what is happening? What is happening in this particular graph? What is happening in this particular graph? So in this particular graph, we can see that the left hand limit and the right hand limit are not at all equal. And when the limit does not exist, if limit does not exist, the function would be definitely discontinuous. First of all, limit should exist at that point, and that limit should be equal to, this is the extra step in continuity, that limit should be equal to value of the function at that given point. Then only we can say that the function is continuous. What is happening in this graph? Can anyone tell? What is wrong with this graph or what is right with this graph? If we see that the left hand limit and the right hand limit are equal, right? So here limit exists at x equal to a. Limit exists at x equal to a. Are you getting my point? Limit exists at x equal to a, but this limit is not equal to value of the function at x equal to a. So here the function is discontinuous. Limit exists, but function is discontinuous. Limit does not exist, function is again discontinuous. Correct? Right? Got it? Yes? So for a function to be continuous, limit must exist, and then we check whether that limit is equal to value of function or not. If it is equal, then continuous. If it is not equal, then function is discontinuous. Okay. Now we will study the concept of one-sided continuity. One-sided continuity. Okay. So the question is, the graph is in front of you. The question is whether this function is continuous at x equal to a. Function is continuous at x equal to a. Now you can clearly see that x tend to minus a minus is not in domain. Is not in domain. Right? X tend to a minus is not in domain. I cannot go with the value which is slightly less than a. I can't do that. I can go after a, but I cannot go beyond a. Are you getting my point? So a minus is out of the question. We won't look for a minus. Rather, what we look for is limit of that function at x tend to a plus should be equal to f of a. Only right hand limit. In case of a, we will check only for right hand limit. We don't need left hand limit. If right hand limit and f of a are matching, then the function is continuous at x equal to a. One-sided continuity. Why? Because a minus is not in domain. Same goes with continuity at b minus. Continuity at x is equals to b, right? So for b, which limit we are going to check? Tell me. For b, right hand limit or left hand limit? We cannot go right in the right of b. We can go towards the left of b. So limit of f of x, x tending to b minus should be equal to f of b. Left hand limit of b should be equal to function of b. Yes, I will tell you one more time. I will tell you one. No, b plus, no b plus. I cannot go up more than b. I have to go less than b. I can't go right of b. How can I go right of b? Because see, I have this much window only. I can go right towards right. I can go towards left of b. Towards right of b, I have nothing. Do I have anything towards right of b? No. We don't have anything post b. We have to come towards b. Are you getting my point? This is the concept of one-sided limit. Okay. Done. One-sided limit done. So let me just write it one more time. Function is continuous at x equal to a if right hand limit at x equal to a is equals to function of a. As simple as that. Right hand limit, because I only can approach the function from right hand side. I cannot approach the function from left hand side. I don't have any graph in the left hand side. There is no branch in the left hand side. Okay. And fx is continuous at x equal to b if LHL at x equal to a is equal to f of b. LHL at x equal to b. So here I can only approach the function from left hand side because I don't have anything on the right hand side of b. So left hand side. Getting my point? Alright. Okay, so this is just a one-sided limit. Perfect, clear, correct. Alright. Now, just like we studied that in limits, that exponential function, logarithmic function, trigonometric function, right? Polynomial function. Can you see these functions are continuous in their domain? This thing we know sure short. Now if given, फिर दोनों check करेंगे 100%. Yes, yes Ayush. If given, if you have anything in the left, obviously that's what we studied, na? That's what we studied. Left hand limit is equals to right hand limit is equals to function of a. Why? Because I have something in the left hand side of a, I have something in the right hand side of a, I have the value of function at a. So we will check from all the sides. But in this particular case, I don't have this left hand side of a. I don't have right hand side of it. That's why we are going to check only left hand side. Okay, got it. So we know polynomial function, we know logarithmic, this is log x. Now can you see y is equals to log x? This log x is continuous in its domain and its domain is x greater than 0. It is continuous in x greater than 0. The graph is smooth, the graph is not breaking. So logarithmic function is continuous in their domain, Okay. What about this? This is y is equals to tan x. So can you see tan x seems to be discontinuous function. But trigonometric function is continuous in their domain. So tan x is discontinuous at pi by 2, 3 pi by 2, which is not in their domain. So tan x is वैसे तो discontinuous function, but tan x is continuous in its domain, because odd pi by 2 is not in the domain of tan x. So tan x is discontinuous at tan x is discontinuous at 2n plus 1 pi by 2. So tan x is continuous in its domain, but tan x is discontinuous at odd pi by 2. Sorted? Same goes with exponential function. Exponential function continuous in their domain, right? What about discontinuous function? Let us see some examples of discontinuous function at least. Yes? Let's talk about discontinuous function. So this is step-up function. I already taught you this. One more time. Graph of step-up function. So this is, you can clearly see that the graph clearly shows that at 1 the graph is breaking. At 2 also the graph is breaking. At 0 also the graph is breaking. So at all integers, the function is discontinuous. The graph of, or the function, greatest integer function is discontinuous at all damn integers. Are you getting my point? Yes. What about fractional part of x? Same thing. The function is breaking at 1. The function is breaking at 2. The function is breaking at 0. The function is breaking at -1. Can you see? Again, all damn integers. All integers. Discontinuous. Right? All the values of integers, all the values of x where x is equals to integer, the function, both the functions are discontinuous. Yes, perfect. Signum x, very important. What is the graph of signum x? So signum x at x equals to 0, signum x will become 0 when your x is positive, when your x is negative. Signum x is -1. So the continuity occur at x equal to 0. So the function is discontinuous only at x equal to 0. Okay. So greatest integer function discontinuous at all integers. Fractional part of x discontinuous at all integers, but signum x is discontinuous only at x equal to 0. Is that clear? Please comment in the chat box, because post break I can see there is no Josh, nothing. Maybe you have not had your dinner or what, I don't know, but I can clearly see that your energy is not that great. Please pepped up, charged up. Please pep up, charge up, recharge yourself. Yes, Luxury Hitler, clear. Oh, Gayatri, no. What no? Okay, there is a question. JEE Main 2020. Alright, so, okay. You know what? We have spent so much time in studying limits. You all were saying, ma'am, speed up, fast, limits, when will the lecture will get finished. But trust me, let me tell you that the continuity chapter is 60 to 70% limits only. We are going to solve limits only in this particular chapter as well. Are you getting my point? So now I don't have to like explain it again and again, because same limits concept we are going to apply, same calculation, same everything, binomial, standard limits, everything. Yes, Vijay Lakshmi. At +1 and -1, signum function is continuous. Okay. So try this question 2 minutes. I can see ye -1 le lo, ye take it -2. 1 and 0. Okay. 2 minutes I'll give you. So question says your fx is equals to sine of a plus 2x plus sine x by x. Okay. And then b, and then this is continuous at x equal to 0, then a plus 2b is equals to. Now the question says that your fx is continuous at x equal to 0. What does that mean? What does that mean? If any function is continuous at x is equals to 0, that means left hand limit should be equal to right hand limit should be equal to value of function at x is equals to 0. Only this. Only this. That's it. Just apply this. Just apply this. You can call it Bible of continuity. Only this statement you will need. Just apply this. You will surely get the value of a plus 2b in like nanoseconds. Fraction of seconds you will get this. Quickly. Yes, Vijay Lakshmi. LHL should be equal to RHL and should be equal to value of function at x equal to 0 because continuous at x equals to 0. Alright. So left hand limit. For left hand limit, what should we do? For left hand limit, what should we do? For left hand limit LHL, that means we are talking about x is equals to 0 minus, right? That means x is less than 0. So we should focus on this particular branch or this particular definition, right? Okay. So we need to figure out. So left hand limit LHL would be equal to limit x tend to 0 minus and this value sine of a plus 2 x upon x plus sine x by x, right? Yes. So for this I need to multiply and divide. Pure limits question. I need to multiply a plus 2 so that this will become 1 and I need to multiply a plus 2 over here. So this is 1 into a plus 2. This is coming out as a plus 2. This is coming out as 1. So left hand limit is coming out as a plus 3. Clear? Left hand limit is coming out as a plus 3. Clear or not? What about the value of function f of 0? F of 0 is coming out as b. Clearly in the question, right? So LHL is this. F of 0 is b. What about RHL? RHL would be limit x tend to 0 plus. In RHL, we have to go greater than 0. X is greater than 0. So here, this is the expression. So x tend to 0 plus. Okay. Let me just write this. This x plus 3x square raised to power 1 by 3 minus x cube root of x upon x की power 4 by 3. Now we have to solve it. Take out x raised to power 1 by 3 common. Take x raised to power 1 by 3 common. The moment you take x raised to power 1 by 3, what will you get is 1 plus 3 x raised to power 1 by 3 minus 1 whole upon x raised to power 1 dot x raised to power 1 by 3. I have splitted this. X raised to power 4 by 3 will be equals to x raised to power 1 into x raised to power 1 by 3. These two will get cancelled out, right? Limit x tend to 0 is there. Apply binomial theorem over here. 1 plus very little quantity x tend to 0. 1 plus very little quantity raised to power 1 by 3. So 1 plus this power will come in front, 3 by 3x minus 1 upon x. 1 cancel, 3 cancel, x cancel. This right hand limit is coming out as 1. Left hand limit is coming out as a plus 3 and then value of function b and then 1. Okay. So LHL is coming out as a plus 3. That is f of 0 minus. F of 0 is coming out as b and f of 0 plus, that is your right hand limit, is coming out as 1. Have a look. Right hand limit is coming out as 1. Binomial expression. So I have taken x raised to power 1 by 3 common. The moment you take x raised to power 1 by 3 common, it will become 1 plus 3x raised to power 1 by 3 minus 1 upon x. Apply binomial expansion. So 1 by 3 will come in front. We have studied right in the session. So 1 by 3 will come in front, 3 gone, 1 cancel, 3 gone, x cancel, 1 will be left out. So 1 is this. So the value of b is coming out as 1 first of all. And a plus 3 is also 1. So a plus 3 is equals to 1. That means a is equals to minus 2. So minus 2 comma 1. So minus 2 plus 2 into 1. 0. Option D, 0 is absolutely right. 0 is absolutely right. Anyone who still have some doubts, who want me to repeat it, who want me to explain it one more time, or who has any doubt, any doubt? Any doubt? Very simple, Gotram Raj, very nice. If you're finding it simple, then all the credit goes to limits chapter. You have studied limits so nicely, so well, so that continuity, you are feeling that continuity is a cakewalk for you. Okay? All right. A student is saying repeat. Okay, I'll repeat it for you. So see, this was the question. One last time I'll repeat. This was the question. So RHL I'm going to repeat first. RHL, that means I need to calculate f of 0 plus. F of 0 plus, that means x is greater than 0, right? X is greater than 0, that means this particular branch. So I need to calculate limit of x plus 3x square raised to power 1 by 3, x raised to power 1 by 3, and x raised to power 4 by 3 can be written down as x raised to power 1 by 3. Can I do that? Now you just need to take common. What should you take common? X raised to power 1 by 3. Take common quickly. X raised to power 1 by 3 out. Inside the bracket you will get 1, right? Plus 3x. Power 1 by 3, and here minus 1 because x raised to power 1 by 3 is outside. X raised to power 1, x raised to power 1 by 3, x raised to power 1 by 3, x raised to power 1 by 3 gone. Now Chhaya Yadav, do you remember 1 plus x raised to power n is equals to 1 plus nx approximately? Only when x is very less than 1. Only when x is very less than 1. So it is happening right here, right now. 1 plus very small quantity raised to power 1 by 3. So this 1 by 3 power will come in front. So 1 plus n x minus 1 whole upon x, limit x tend to 0. 1 से 1 गया, 3 से 3 gone, x gone, 1. This is your right hand limit. Now your right hand limit is equal to f of 0 plus is equals to f of 0. So what is f of 0? Your right hand limit is coming out as 1. F of 0 is clearly given as b. So the value of b is 1. Now you just need to do the LHL wala part. I'll give you the PDF. This is your responsibility to understand right after the session. Okay, I'm not explaining this particular thing again to you because I know, I have trust in you that you will surely solve LHL. Okay, all right. So there are multiple types of discontinuity which I want you to know. So the very first type of discontinuity is removable discontinuity. So there are some type of question which says that find the value of a for which the function becomes continuous. That means you can make some functions a continuous function. You can make some function continuous function. So that would be in removable discontinuity. So what happens in removable discontinuity is isolated point and missing point. So what happens is, suppose you have a graph like that, and at x is equals to a, you have an isolated point. Okay, so this function clearly is discontinuous function at x equal to a. x equal to a. But what happens in this particular thing, you can clearly see LHL is equals to RHL at x equal to a. Agree or not? LHL and RHL are equal, but only thing which is lacking over here is this particular point. So we just need to like remove this point from here and fix it over here just like a game. You just need to pick this point from here, place it here so that this become a smooth graph, a continuous graph. So these kind of continuity are called removable isolated point continuity as shown in figure, isolated point. So this one part is missing. One part is, you can say, not missing but isolated. One part is isolated. Like for example, if you have any computer and computer has so many technical parts, right? One part is there in your home but not inside the computer. It's there in some other room, some store room. So this is isolated. That particular part, you have isolated that particular part. But if you find that part, if you fix that part in that computer, the computer will start working. So this is isolated point. What is missing point? Missing point means that you have again a computer, the part is missing, but that particular part is not at all in your home. It is lost, completely lost. It is completely lost. Missing point. So how does a missing point continuity look like? Like this. Like this. The point is absolutely missing. Nowhere. This is also, but again, here also LHL is equals to RHL. So what we can do is we can define the function, we can buy that part, we can buy that new part, we have to go to the store, we can still buy the part, we can fix the computer. So we just need to fill the circle, we need to reintroduce it, and your computer will work and your graph will be smooth, it will be continuous. Got it? Isolated point has a point but somewhere else. Missing point is we don't have that point. We need to create that point. Okay. So this is removable discontinuity. And what about non-removable discontinuity? Non-removable discontinuity. So non-removable discontinuity means, you know what? Limit does not exist. When the limit does not exist, you can't do anything about it. So first one is finite. So that simply means that here we have seen the case also. Here the graph will look like this. Can you see that the left hand limit and the right hand limit are finite? Left hand is finite. For example, left hand limit is 2, right hand limit is 3. Both are finite but both are not equal. Both are not equal. Left hand limit and right hand limit are not equal but they are finite. Infinite, what does infinite mean? Remember that graph mod cortex, right? So the graph looked like this. Remember this graph? So at pi we were discussing this at pi. So LHL is also infinity. RHL is also infinity. But since both are not finite, limit does not exist. So in non-removable discontinuity, limit does not exist at all. Either finite or infinite. And the third is oscillatory discontinuity. What is oscillatory discontinuity? Like this. So oscillatory discontinuity is, what happens is, so if you put x tend towards 0, you can't 0 plus and 0 minus, you can't put x equal to 0, by the way, right? So the moment you put x equal to 0, it will become sine infinity. What would be the value of sine infinity? The value will oscillate between -1 to 1 very quickly, like this, like this. The value will oscillate. I'll show you how it oscillates. The moment you put 0 over here, it will become sine infinity, and the moment you see this is the point 0, and the moment you become close to 0, the value will oscillate between -1 to 1 very fast, and you are not able to determine whether the value is +1 or all you know is the value is between -1 to 1. You don't know the exact value. When you don't know the exact value, limit won't exist. This is oscillatory type discontinuity, which cannot be fixed at all, which cannot be made continuous. So this function looks continuous, by the way. This function looks continuous, but this is a discontinuous function at x equal to 0. At x equal to 0, it is giving some problem, some trouble, because you don't know the value. What is sine infinity? It can be anything between -1 to 1. We don't know. We don't know the value. That's why it is oscillatory discontinuity. Right? Okay. Clear? Alright. Continuity in an interval. Continuity in an interval. So, have you observed one thing? That we have been talking about the point continuity. Every time I tell you about the continuity, I talk about this point at x equal to a. And the definition also I have given you. The function is continuous at x equal to a, left hand limit at x equal to a, right hand limit at x equal to a, value function at x equal to a should be equal. So I am always talking about continuity at a point. Even if you notice the title also says continuity at a point. So right till now we only know how to check continuity at a point. We only know this. Till now we only know how to check continuity at a point. One-sided continuity also, what do we study in one-sided continuity? We studied at x equal to a, x equal to b. Right? Now we have to understand that continuity in an interval. Right? Continuity in an interval. So for example, yes. For example, we need to check continuity in a comma b. So there are three things which we are going to check. For continuity in an interval, three things we are going to check. Okay? Three things we are going to check for continuity in an interval. The very first thing we need to check is the function should be continuous in open interval. A comma b, all points. So the function should be continuous in the open interval, all points. That means starting from A, the graph should be smoother, smooth. Pen should not be lifted. No jumps, no break. That's all. Alright. So A to B, open interval sorted. Okay. Now the function should be continuous at A. At x equal to A also function should be continuous. That simply means that RHL at x equal to A should be equal to value of function at x equal to a. That means f of a plus should be equal to f of a. This is the second point. Because for a we are going to check right hand continuity. This exists. Even if this exists, we don't care about left hand side of a, because in the question itself it is given that we need to only go right of the A. Don't go towards the left of the A. So delete whatever information, even if you have it, we don't want it. And you can't go after B. You can't go towards the right of B. Just delete it. So at x equal to B, your function should be continuous. That simply means left hand limit at x equal to B should be equal to value of function at, that means f of B minus is equals to f of B. Are you getting my point? One-sided continuity, that's it. Very good, Vijay Lakshmi. Are you getting my point? Continuity so continuity in closed interval, if you are going to check, it will become like this. But agar in case they say continuity in an open interval, so simply check all the points of the open interval. But you will say, what are you saying, ma'am? What are you saying, ma'am? Are you telling me to check the continuity of the function at all points between A and B? There are infinite points between A and B. Are we going to check each and every point? It will take infinite years. Like our next generation will be able to do that. Their next generation will be able to do that, and the values will not get finished, get completed. Right? So I have a hack for you. I have a hack for you. So what happens is, there are a few hacks. For example, I already told you, if the function is polynomial, if the function is trigonometric, if the function is logarithmic, if the function is exponential, then the function usually remain, yes, then the function usually remain continuous. Okay? Alright. So that means there are some suspicious points. There are some doubtful points. Only on those points we are going to check. We are not going to check at all points. What are those doubtful points? Very important, very, very important. What are those doubtful or suspicious points? The very first thing, as Vijay said, boundary points. Boundary points. What are boundary points? Do you understand boundary points? If in case interval is given, because we are talking about interval. We are talking about interval. So if in question says that x belongs to 2 to 5. So what are boundary points? 2 and 5. Right? Close bracket, close bracket. What are boundary points? 2 and 5. So you just need to check for 2 and 5. Boundary points clear? Second, when the definition changes, for example, if I tell you there is a function f of x is equals to x square and minus x greater than 1, x less than or equal to 1. Can you see the definition is changing at x equal to 1. So what is the doubtful point in this particular situation? X equal to 1 is the point where the definition is changing. Third and most important, if you have this greatest integer function of fx or fractional part of fx, so whenever fx is becoming an integer, that would become your doubtful point. You have to check at all the integers. Alright? And whenever you have signum of f of x, right? So this f of x, whenever f of x is 0, this is your doubtful point. This is only three things you need to remember in the interval. That's it. This is very, very important. Only 3 things remember. Only at these 3 points you need to check. Got it? Any confusion? Shall we start? Shall we start solving problems for continuity in an interval? No, Vijay Lakshmi, only at x equal to 0. Signum inside the, whenever there is a 0 inside the signum function, it's a function Divyesh. Yeah, Gotram Raj saying, ma'am saved infinite years. Yes. So we don't need to check at every point. I'll show you with the help of a question. So see, this is the question. So in this question it is clearly mentioned that there is a function which is continuous on R. The question has not given any point. Whereas if I show you the previous question which we solved clearly is continuous at x equal to 0. This particular thing is talking about a point, and the new question, the current question is talking about an interval. Now we need to apply our brains. So this is a trigonometric function, continuous. This is a modulus function. Modulus functions are continuous. Trigonometric functions are continuous. Okay. So in this particular situation, I can only I can only see one thing, that the function is breaking at x equals to -1 and x equal to 1. -1 and 1 are the checkpoints. So these are the only two doubtful points in the whole -∞ to infinity, in whole big interval, in the full number line. We have just got only two doubtful points. Only these 2 points we need to check, rest done. Very easy question. Are you going to do that? Are you going to solve for me? Shall I give you 2 minutes? Please solve it, because trust me, it is a 1 minute question, not even a 2 minute. It looks big, but it is very simple. It is looking big, it is very simple. Okay, all right. Yes. See, so I was planning that I should end the session around 9:30 or 9. Luxury Hitler, sharp edge is considered as continuous function? Yes, but not differentiable. That we will see. But I took the session a little longer. I am having fun. Are you guys not having fun? Because the chapter is taking time. Actually, what happens is, there are some chapters which deserve some time, some good time. So I am giving that time to this chapter, right? And you also should give that time to understand the chapter. Then once you understand, once you master the concepts, then there is only questions, questions and questions. Yes, 9 o'clock I was planning to end, but it is already 10:18 and it will go, I guess, till 11 maybe. Okay. Checkpoints 2 minutes. Okay. So -1 and 1, right? -1 and 1. Let's talk about f of -1 is equals to left hand limit is equals to right hand limit. Okay. So what is f of -1? So f of -1 we will get over here. And what is f of -1, the right hand limit? What would be the right hand limit? So right hand limit will get from here. Left hand limit will get from here. Right? This is left hand limit because x is less than -1. This would be right hand limit. So what is the left hand limit? Simply for left hand limit you just put the value of x -1 over here, 2 sin pi by 2. So left hand limit, this is your left hand limit. That means x is less than -1. So for this you need to put -1 in this, 2 sin pi by 2. So 2 sin pi by 2, this will become 2. This is your left hand limit. What about value of function at -1? The put value as -1. So the moment you put -1 over here, it will become a plus b minus 1. This is value. Right hand limit, no need, because right hand limit will only come like this only. So a plus b minus 1 mod is coming out as 2. So that means a plus b minus 1 is equal to 2. A plus b is equal to 3. That is first option. Or a plus b minus 1 is equals to -2. A plus b is equals to -1. So this, either this or this. A plus b is coming out as 3 or -1. So either A is correct or B is correct. This is wrong, this is also wrong. A or B. Why D? Why D? D to never is the correct answer. Vijayalakshmi, what happened? Vijayalakshmi, what happened? Now at -1, definition is changing at -1, definition is also changing at 1. And now 1 is another doubtful point. Let's talk about x equal to 1. So f of 1 is equals to f of 1 minus, this is your left hand limit and this is your right hand limit. What would be the value at x equal to 1? So x equal to 1, so that would be a plus b plus 1 ka mod is equals to what would be your right hand limit? This is your right hand limit. We don't need left hand limit actually. Right hand limit you put Sine pi into 1. So sine pi is 0. So 0. So a plus b plus 1 is equals to 0. That simply means that a plus b is minus 1. Right? So a plus b is minus 1. So this is rejected obviously. Right? Because continuity should be at both points, minus 1 and 1. So a plus b is equals to minus 1 is giving both continuous options. So option B is absolutely right. Perfect? Clear? Yes. So we just did two things, nothing great. We just made the function continuous at x equal to minus 1 and 1. The moment we make continuous function continuous at minus 1, we will get these two things. And the moment we make function continuous at x equal to 1, we will get one thing. Clear? Okay. One more JEE Main 2023. Acha, tell me, shall I give you homework or shall I do it with you? Shall I give this to you as a homework, or shall we like solve it? By the way, there is some correction in this question, not correction, but this is like power. 1 plus, let me just rewrite it, this expression. So this is 1 plus cos x mod, then this is on the power, lambda upon mod cos x, like this. Okay. Homework, do this, we'll do it right now. Okay, right now. Right now. Okay. So again, in the question it is mentioned that the function is continuous at x equal to pi by 2. Please remember, this is not multiplication, this is in the power. I have corrected it. Okay. Yes, we are doing it now. So we are making the function continuous at x equal to pi, right? So that means f of pi by 2 is equals to f of pi by 2 plus, that is your right hand limit, f of pi by 2 minus left hand limit. Okay, I'll give you 2 minutes. 2 minutes to solve this question. You'll solve this question and then I'll be solving this. Okay. And I already told you, whenever you see the question of limit, the problem of limits, what do you do? Remember that. Always check form check. Then you will be sitting in your JEE Main 2024 first and second attempt both. The moment you see limits question na, you will hear my voice. Form check. All right. Let's just start solving it. This is in the power. So first of all, let's calculate the left hand limit. That means limit of this function where x is tending to pi by 2 minus. That means x is less than pi by 2. That means this particular branch. So this will become limit of x tend to pi by 2 minus 1 plus mod cos x raised to power lambda upon mod cos x, right? 1 raised to power infinity. How do you solve it? Do you remember? So limit x tend to pi by 2 minus e raised to power. The power will come in front. So lambda by cos x mod, and subtract 1 from the base. Subtract 1 from the base. 1 and 1 gone. Cos x also gone. So this is e raised to power lambda is coming out as your left hand limit. Left hand limit is coming out as e raised to power lambda. Okay. And what is your f of pi by 2? It is mu. So this is nothing but mu. E raised to power lambda is mu. What about your right hand limit? I'll need only this space to calculate. Right hand limit is equal to limit of function x is tending towards pi by 2 plus. Pi by 2 plus means this particular branch. Can I write it as limit of function? So e raised to power tan 4x upon tan 6x. Ninja technique. 4 by 6. E raised to power 4 by 6 is the answer. E raised to power 2 by 3. So now equate all the three values. E raised to power lambda is equals to mu is equals to e raised to power 2 by 3. Clearly mu की value तो 2 by 3 है. Lambda is nothing but 2 by 3. Right? Just put the value. You'll get your answer. 9 times lambda. 9 times lambda. So 9 times 2 by 3, 18 by 3. Which is 6. Okay, plus. 6 times log mu. Log mu is log e की power 2 by 3. Plus. Can you see this is mu raised to power 6. Now mu raised to power 6 would be what? E raised to power 12 by 3. E raised to power 12 by 3. And minus e raised to power 6 lambda. So 6 2s are again 12 by 3. So these two are getting cancelled out. 2 by 3 will come in front. 3 6 are 6 and 4. So 6 plus 4 is your answer. So 10 is your correct answer. Option D, 10 is correct answer. Left hand limit, right hand limit, value of the function. Done. JEE Main 2023. Pat your back. Pat your back. You have solved JEE Main 2023 problem. I have already told you that to check continuity in an interval, you have to check doubtful points. I have already told you. Again, I am repeating. What are the doubtful points? Boundary points. Points where definition changes. Again, I am telling you, right? Third, whenever you get integer inside GIF of x, and whenever you get again inside fractional part of x also, the moment you get integer, and inside signum of function, whenever you get 0 inside signum function, these are the three doubtful points. Will you remember this? If you remember these 3 points, your life will be sorted. I'll save your infinite years. Okay. Now theorems on continuity. Theorems on continuity. Simple चीज है. अगर आपके पास okay, not Hindi, English. Okay. If you have two functions, suppose fx and gx, your fx is a continuous function. Your gx is also a continuous function. Alright? Alright? Fx is also continuous, gx is also continuous. For example, let's say fx is your sin x and gx is your x plus 1. Right? Whenever you have both function continuous, then your fx plus minus gx is also continuous. Your sum difference product is also continuous and division is also continuous. What does that mean? That summation, difference, product, division of two continuous function is always continuous. Are you getting my point? Sum, difference, product, division of two continuous function is always continuous. Here is the example. So if you have two functions, sin x plus 1, continuous. Sin x minus 1, continuous. Sin x into x plus 1, continuous. Sin x upon x plus 1, continuous. Here there is one slight condition, just that gx should not be equal to 0, because whenever gx is 0, the function will become continuous. Yes, Luxury Hitler, I already said what you have written. Okay. Now, if one function is continuous and another function is discontinuous, when one function fx is continuous and gx is discontinuous, then my dear students, their sum and difference is definitely discontinuous. Sum and difference is definitely discontinuous. What about the product? I cannot say. We need to check. We need to form that product and we need to take it as a new function. We need to check the continuity of the new function. Again, cannot say, cannot comment, may or may not be. It will depend. There are both cases. Again, if fx and gx both are discontinuous function, then we cannot say, cannot say, cannot say, cannot say, cannot say, may or may not be, may or may not be. So certainly what we can say, certain, what is the short thing? If two functions are continuous, then we are sorted. Plus, minus, product, division, all is continuous. Okay. When one is continuous, one is discontinuous, their sum and difference is discontinuous. Rest everything we cannot say, we cannot say, we cannot say, may not be, may not be, may not be. That's it. As simple as that. Okay. Right? This is the master table. Master teacher, master table. Vedantu's master table from master teacher. Okay. Yes. One more thing I want you to know, this is very important, and I guess Luxury Hitler was asking this question. So if you have a function f which is continuous, then modulus f will also be continuous. For example, if you have this quadratic expression, right? If I plot the parabola out of this, I guess plus 1 and minus, so minus 1 and 4 are the roots, and minus 4 is this. Okay, this is the parabola. So my fx is this, my function is this. Is this quadratic polynomial continuous? Yes, ma'am, 100%. This is a polynomial and we have in the beginning understood that polynomial functions are continuous. What about this gx, which is nothing but modulus of this? So if I try to make modulus function, this is mod x square minus 3x minus 4, you know how will it look like, right? So it will look like this. We take a mirror image about the x-axis and this. So this is minus 1, this is 4. Okay. So this is again, I have not lifted the pen. Can you see the graph is smooth? Like this, like this, like this. So this is a theorem actually. This is the theorem. So if I tell you the log x is continuous in its domain, right? So what about mod log x? Continuous. Mod log x is continuous in its domain. You know that. Okay. Let us see some more examples. Okay. Clear? Perfect. If I talk about mod of log x, Tell me, mod log x continuous or not? You will say, okay ma'am, wait. So log x is this. This is continuous. In its domain, so it's continuous. Yes ma'am, log x is continuous, so mod log x is continuous. Are you getting my point? Okay. Remember, it is continuous. I have said continuous. I have not said differentiable. Be alert, be careful about the terms I am using. Okay. Now, this is one of the thing which is very important. What about the continuity of composite functions? What about the continuity of composite function? What if you will get a composite function and you need to calculate the continuity of composite function? This is very important. Take 10 seconds break because I want you to understand this very nicely and I want you to give maximum undivided attention over here. Okay. So what do you think? What will we do for composite function? What do you think? What should we check? What all x should we check? What should be the doubtful points? What should be the doubtful points in case of composite functions? At corners, range in domain, luxury Hitler, little correct. Yes, very important but very interesting. Okay, for continuous function you just have to check two things. Just have to check two things. The very first thing is very simple. The very first thing is you just need to check the inside function, the points where the inside function is discontinuous. All the points where the inside function is discontinuous. So suppose you have f of g of x. What is the function which is inside? Which is the function which is inside? G of x is inside, right? G of x is inside. You will check all the points where gx is discontinuous. So the first thing is very pretty easy. Yes, Shreyadeep, very close. First point clear? Will you be able to check all the points where gx is discontinuous? Okay. Now, second point, I need your maximum attention in the second point. Listen to me carefully. So, for second point, what you will do is, you will calculate all the points where fx is discontinuous. For second points, it's a process where you need to calculate all the points where fx is discontinuous. So, for example, fx becomes discontinuous at x equal to c, for example. So, that simply means that the moment you will have c inside the function f, you will be in trouble. That's what you are saying, right? Okay, in the second point, we have calculated all the points where fx is discontinuous and now I have the point. I know that my fx is discontinuous at x equal to c. That means what I am saying, that the moment I have c inside of x, I'll be in trouble. Yes or no? Getting my point? Okay. But what is inside of f? Can you tell me? What is there inside of f? I can clearly see gx is inside of x, right? So, gx is equal to c is what we need to check. The moment gx will be equal to c, at that particular moment, c will be inside of f. And that would be the trouble point. Yes or no? Shall I tell you one more time? So the point is gx is equals to c given that fx is discontinuous at x equal to c. Okay. And now there are some people I know who would be saying, ma'am, I couldn't understand. I will show you and you will see how simple this thing is. How simple is this thing? Okay. One more time. Okay. Both the points again. So, yes. For the composite function, yes. For composite function, what is the first point? First point is simply very easy. First point is you need to check whether the inside function is discontinuous. You need to check whether the inside function, what is the inside function? Gx. Okay. First point is very easy. You have fx, you have gx. Can you calculate at what all points gx is discontinuous? You can calculate. I will show you in the next question. What is the second point now? For second point, you need to calculate the points where f of x is discontinuous. Check, calculate all those points where your f of x is discontinuous. Okay. The outside function, the function which is present outside. Suppose you've got, okay ma'am, fx is discontinuous at x equal to c. Okay. Suppose you have two functions, right? F of x and g of x. So suppose you realize that, okay ma'am, now I know that this fx function is discontinuous at x equal to c. That simply means that you are saying the moment I put c inside the f, I will get discontinuity, yes or no? F of c will create discontinuity, right? Now compare these two. Look at this and look at this. Look at these two. Compare these two. Clearly, we can see that gx is inside of f here, okay, and c is inside here. So this is the point of trouble. This is the point of trouble. So what is the second step? Just calculate all those points where fx is discontinuous. Suppose f is discontinuous at x equal to c, equate it to gx. I will show you, okay. I will show you with the help of the problem. Okay. Let's solve it with the help of the problem. You will understand definitely. So we have f of g of x. Okay. We have our theory f of g of x. So first, what was the first point? The first point was check the discontinuity of gx. Check the discontinuity of gx. Where is gx? Here is gx. So discontinuity of gx. Tell me the discontinuity of gx. Clearly discontinuity of gx is nothing but x equal to 0. Right? Find the points of discontinuity now. So x equal to 0 is the point of discontinuity. This is the first thing. Point of discontinuity is what? X equal to 0. Clear? Okay. Now so this was the first step. What was the second step? Check the calculate the discontinuity of fx. Second step. Calculate discontinuity of fx. ठीक है, तो हमने निकाला. What is the discontinuity of fx? Tell me. When 2x minus 1 is equals to 0, that means x equals to half. So x equal to half. Okay. So calculate discontinuity on fx. Suppose it is x equal to half. Equate it to g of x. So g of x is equals to half will give you final discontinuity. So g of x is equals to half. So g of x is equals to half. What is g of x? So 2 plus x upon x is equals to half. This implies, just solve it. 4 plus 2x is equals to x. So this will become x is equals to minus 4. What is another point of discontinuity? X equals to minus 4. So basically in here what I am trying to say is, whenever we have half inside of x, I will get troubled. Yes or no? Whenever I put half in place of x inside f, I will get into a trouble. Yes or no? Okay? Okay, alright. So whenever I place half inside of f, that means gx is equals to half will create a trouble. Whenever you see half inside of x, half inside of f will create a trouble, correct? So whenever you put half inside of f, matlab gx equal to half, the moment you put gx is equals to half, you will be in a trouble. That means gx is equals to half will give you the trouble points. Gx is equals to half will give you trouble point. X is equals to -4. Those 2 points of discontinuity, 2 points of discontinuity. So always remember these 2 points in when you are calculating composite function. Okay? Clear? Yes? Alright. Now there are some functions which are only continuous at one single point. There are some functions which are only continuous at one single point. What does that mean? That these functions are discontinuous at each and every other point except that one point. Which are these functions? How does these function look like? How does these functions look like? So here we have, here q is representing rational and this is not rational. Rational and not rational. Vaishnavi, how many points of discontinuity? 2 points of discontinuity now. X equals to 0, x equal to -4, 2 points of discontinuity. Okay? Yes. So these are a few kind of functions which are continuous at single point. This is the type, this is how they look like. If you try to plot the graph of these kind of function, you will not be able to put, because what will happen, suppose you say I'll start putting the creating the graph from x equal to 1 to x equal to 2. Okay? Alright. So x equal to 1 is rational. So you will get at x equal to 1, you will get value 1. Okay? This is the point. What about just right after 1? What about just right after 1? So right after 1, you will have maybe an irrational value. For example, for irrational value, you will get a 0. So here you will have this point. Right after that value, you will maybe have a rational value. Then irrational. Are you getting my point? Plotting the graph is not at all you cannot plot the graph. But what we know about these functions is, these are those kind of function which are continuous at only one point. How do you calculate that point? Is you just have to equate these two. You just have to equate these two. X is equals to 0. This is the only point where this function is continuous. So if someone asks that at what point this function is continuous, you will say x equal to 0. Only at x equal to 0 the function would be continuous. How? Let's say, try to plot the graph. The moment you put x equal to 0, 0 is a rational number, you will get what? X is 0 here, so 0. The moment you go right on the right hand side, so it will become irrational, the value will still be 0 and the value left hand side will still be 0. Only at 0 the function is like connected, rest all points the function is scattered, discrete function. Getting is only continuous at x equal to 0. Okay? This function, can someone tell me at what point this function is continuous? Which of the following function has single point continuity? So this particular thing, so we need to equate these two. 1 is equals to 0, not possible. So this is discontinuous everywhere. This function is discontinuous everywhere. Yes? What about this? What about this? So this function is continuous when x is equals to 1 minus x, 2x is equals to 1, x is equals to half. So this function is continuous only at x is equals to half. Yes, Luxury Hitler, correct. Got it? Single point discontinuity, single point continuity. Clear? Differentiability. Yes, differentiability. Shall we start? Okay, let's take 2 minutes. We'll start it after 2 minutes, okay? You also drink water, I'll also drink water. Shall I reveal the next chapter? Shall I reveal the next chapter? So the next chapter is sequence and series. Dan-ta-dan. Alright, Captain Shreyas is here. Yes, yo, high on energy. Alright, let's recharge ourselves. Alright, let's start with the differentiability now, the last topic, okay? Let's start with the very basic, the concept of tangent, okay? So here we have a point P, we have a point Q, and we have a point R, okay? What is PR, by the way? If I join PR, what is PR over here? Sir, I feel like time traveler in your class. I don't understand this. What is time traveler? Okay. Chalo. Can anyone tell me what is PR over here? What is PR for this curve? What is PR for this curve? Tangent are deleted. Yes, tangent are deleted. I am not getting into the tangent, but differentiability requires some knowledge of tangency. That's what I am trying to tell. Okay. So PR is called, or you can call it a secant as well. and PQ is also what? A secant, right? So what happens is when this, so this is point P, this is x is equals to A, and this is what? X is equals to A plus H. This is nothing but x is equals to A minus H, right? Right? Okay. So if I talk about this secant PR and if I talk about this secant PQ, this secant PQ, right? And if I coincide this PQ, this Q will tend towards P and this R will also tend towards P. What I am trying to say is this Q tend towards P, and R is also tending towards P. So then what will happen is only point P will be left. Imagine. So here this secant will become a tangent like this. This will become your tangent and this PQ will be like this. So PQ will also be the tangent. So you will have a PQR, a single line, and this is what we call a tangent. Okay, alright. When will it happen? When H will tend towards 0. When H will tend towards 0. Okay, alright. Clear? Perfect. Alright. So secant, the limiting condition of secant is what we call a tangent. Okay. Now to understand differentiability, you have to have a little knowledge of tangency, otherwise you will not be able to understand the differentiability. What is differentiability? So differentiability, a function is said to be differentiable at a point P if it has a unique tangent of finite slope at point P, right? If it has a unique tangent of finite slope at point P. So what will happen is, if I plot a curve and if you are able to draw a unique tangent at, let's say, point P, okay, alright, let's say at point P, then, and that should be of finite slope, then only you can say that the function is differentiable at this point P. And remember, there should not have any jump or sharp corner, just like the luxury Hitler was asking. Just like the luxury Hitler was asking that what if we have a sharp corner? What if we have a jump? I'll show you. Okay. So let me just ask you, again your turn. Let me just ask you, is this function differentiable? Is this function differentiable? How will you check whether a function is differentiable or not? So what you do is you try to draw a tangent. The moment you try to draw a tangent, you will realize, okay, I am able to draw a tangent over here. Okay, this is the tangent. What about this? Again, you will be able to draw a tangent over here. So you are not drawing a unique tangent over here. So that means your function is what? Not differentiable. Not differentiable because we have a jump or we have a break. So we cannot draw a unique tangent on this. The function is not at all differentiable. Okay. Alright. What about this? What about this? Is your function differentiable here? Is your function differentiable? Is your function differentiable? No, because we have a sharp corner. Now realize one thing. The students who were telling me, ma'am, no, don't teach tangent. Now I'm going to tell. The moment you try to draw a tangent from the left hand side, you will say that this is the tangent. The moment you start drawing the tangent from the right hand side, you will have this particular tangent. So you have how many tangents? 2 tangents. Do you have a unique tangent? No. You don't have a unique tangent. And if you don't have a unique tangent, that simply means the function is not differentiable. Alright? Okay. Let me just ask you another question. This again same. At this point you can see the sharp corner. Why the function is not differentiable at sharp corner? Because you can clearly draw 2 tangents at the same point. So there is no unique tangent. That's why the function is not differentiable. What about this? What about this? The function is differentiable or not? This particular function is differentiable because there is no sharp corner, there is no jump, the graph is smooth, and at each and every point you are able to draw a unique tangent. So this, the only function which is differentiable which we can see is this function. Yes, 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 yes. All right. Perfect. So the condition of differentiability. Let us have a look at the condition of differentiability mathematically. So you have understood, right? You have understood graphically that what happens is, acha, you tell me one thing. Mathematically think like this. What will happen? What is the condition? What will be the condition where these two different tangents become a unique tangent? What should be the condition? So here we can clearly clearly see that these two are two different lines. Why? Because slope of this line is absolutely different from slope of this line. If the slope becomes equal and they are passing through the same point, then only we can say that there is a unique tangent. So for that, what you need to do is, you need to draw a line from the left hand side, which would be, and the slope would be left hand derivative. You have to draw a line from the right hand side. The slope would be right hand, basically the right hand derivative would be the slope of this line. And if these two slopes are equal, then only we can say that the function is what? Differentiable. So that's what we have done. So this is the slope of your right hand derivative, you can say, slope from the right hand side. This is the slope from the left hand side, and this is nothing but your right hand derivative, and this is the slope from left hand derivative. When the slope of left hand derivative and right hand derivative are equal and it is equal to a finite value, then only we can say that the function is differentiable or derivable at x equal to c. Are you getting my point? Are you getting my point? Yes or no? Shall I make it more clear? Shall I make it more clear? Let's take an example. Let's take an example. Okay? All right? Okay. So in this particular question, it is asked that you need to comment on the differentiability of this function at x equal to 1. Okay? Yes. Okay. Okay, Durgamba, I'll repeat it with the help of this question. Okay? I'll repeat it with the help of this question. Okay? So we need to comment on the differentiability of this function. So I have multiple methods to solve this question for you. The first is the very basic method, method number 1, which is you just need to equate left hand derivative and right hand derivative. The condition for a function to be a differentiable function is what? You need to equate left hand derivative to right hand derivative. Okay? Now what is the formula of left hand derivative and right hand derivative? I'll tell you right away. Okay? So left hand derivative, limit h tend to 0 plus f of a minus, okay, yes, f of a minus h minus f of a upon minus h. This is your left hand derivative. What about right hand derivative? Limit h tend to 0 plus f of a plus h minus f of a upon h. This is your left hand derivative, this is your right hand derivative. If these two become equal, then you can simply say that your function is differentiable at x equal to 1. Did you understand this? If yes, then only I'll be proceeding. Otherwise, I'll explain this to you once again. Luxury Hitler, you understood, I know. What about others? Vijay Lakshmi, understood? Blah blue, blee blow, understood? Left hand derivative should be equal to right hand derivative. Left hand derivative, once more, okay. Yes. Let us just come over here from the beginning. Okay. So what is happening? I am trying to understand what is happening at point P. Let us take a point. I am trying to understand what is happening at point P. My point P is x equal to a. I am trying to understand that, whether my function is differentiable at x equal to p, at x equal to a or not, at point P or not. So what should I do? Basically, I should actually calculate the slope of PR. Can anybody help me calculating slope of PR? So PR slope would be what? What would be the y over here? F of a. What would be the y over here? A minus h. Okay. So y2 minus y1. So f of a minus h minus f of a upon x2 minus x1. So a minus h minus a. This is what? Tell me, this is what? This is slope of PR line. Okay. What would be the slope of PQ line? Slope of PQ line. So slope of PQ would be, so this point Q would be f of a plus h. Right. So y2 minus y1. You know the slope, right? From straight lines. F of a plus h minus f of a upon a plus h minus a. y2 minus y1 upon x2 minus x1. What is this? Slope of PQ. Yes. Now, if a function is differentiable at P, there must be a unique tangent. What does that mean? That simply means the moment I put h equals to 0, this r will coincide with P, that q will also coincide with P and will have a unique tangent. And that simply means the moment I put h equals to 0, the slope of PR is equals to slope of PQ. And this, my dear students, is your left hand derivative, and this is nothing but right hand derivative. One more time. Okay, so this is what we have done. So at any given point, if in any particular question, if anyone asks you that you have a function which is derivable at x equal to c, that means you say that the slope from the left hand side, which is this, slope from the left hand side is equal to slope from the right hand side, both should be equal and equal to a finite value, obviously, because unique tangent of finite slope. So this is nothing but slope. This is slope only. Slope should be finite. And if it is finite, the function is differentiable. Here we are talking about x equals to c. I was talking about x equal to a. Okay. So if somebody is asking me to calculate the differentiability of function at x equal to 1, so what will I do? So here, now h is tending towards 0 plus. Yes, both are 0 plus because negative sign is taken care of here only. Okay, so a, now we need to calculate at x equal to 1, replace a by 1. So f of 1 minus h minus f of 1 upon minus h. Limit h tend to 0 plus. Okay, so 1 minus h, that means value which is less than 1. Less than 1 means we are here. So just put 1 minus h in place of x over here. F of 1 minus h. So 1 minus h whole square plus 1 upon minus h. limit h tend to 0 plus. Okay, start solving it. 1 plus h square minus 2h. Okay, and yeah, that's it, plus 1 upon minus h. Okay, minus f of 1 is also there, so minus 2. So 1 plus a 2 and 2 are gone. Okay, and it is coming out as what? So it is coming out as 0, I guess. No. F of 1 minus h. So 1 plus h square minus 2h. Okay, and we have plus 1 and we have minus f of 1 minus 2. So minus 1. So minus 1 gone, h square minus 2h. The moment you put, so it will be h minus h basically. So this is minus h and minus 2. Yes, minus h plus 2. Limit h tend to 0. Okay, so minus h plus 2. The moment you put 0, so you will get the left hand derivative will become 2. Left hand derivative is coming out as 2. LHD is coming out as 2. Got it? What about the right hand derivative? So again, f of 1 plus h. F of 1 plus h, that means x is greater than 1. So twice 1 plus h, okay, minus f of 1. What is f of 1? F of 1 will be calculated from here only. So minus 2 upon h. So 2 and 2 cancel, 2h upon h, so it is coming out as 2 only. Left hand derivative 2, right hand derivative 2, the function is differentiable at x equal to 2. This is your method number 1. This is your method number 1. Is that clear? Is the method clear? Do you want me to repeat? Do you want me to repeat LHD? Yes, Vijay Lakshmi, I got that you understood the question. What about the rest of the people? Clearer than ever, luxury Hitler done. What about others? Thumbs up. Alright. Shall I erase? Clear. I should erase. Okay. This was method number 1. What about my method number 2? Method number 2 is my favorite method actually. Method number 2 is my favorite method. But you can't perform this method in your school. This is only for J. Only for J. Very easy. Very easy. What you need to do is, okay, so you need to calculate right hand derivative, right? So right hand derivative, for right hand derivative you just need to differentiate. For RHD, you just need to differentiate this. So RHD को differentiate करो तो क्या आएगा? 2. What about left hand derivative? For left hand derivative, you need to differentiate this because left hand derivative x less than 1. So what will be the answer? 2x, that's it. And 2x, what will you put? Left hand derivative, you are talking about 1, so you need to put 1 over here. Right hand derivative 2, left hand derivative 2, ninja technique. Yes? Understood the method? The first one is basic method. You should be knowing that method as well. That is never leave your basics. And this is the shortcut, but you can't use this in your school exams. You will get 0 marks even if the answer is correct. Okay? Alright. Okay. Now let's talk about the relation between continuity, limits, continuity and differentiability, right? So understand like this. Limits is a student studying in 7th class. Continuity, a student studying in 8th class. differentiability a student studying in 9th class. Okay, alright. So if I tell you that a student has passed class 7th, if I tell you that a student has passed class 7th, that means limit exists for that particular function, right? Is it necessary that the student has also passed the class 8th? Is it necessary? If you are able to see the mark sheet of class 7th and it is written that okay passed, is it mandatory that the student will definitely pass class 8th? No. So that means if limit exists, that simply means that continuity may or may not happen. That we need to check. If you know that this particular function, for this particular function limit exists, so for continuity you need to check. You need to check. You can't be sure. Okay? Alright. But if a function is continuous, if a function is definitely continuous, that means you are seeing the mark sheet of class 8th. It is written passed. The student has passed class 8th. That means but obvious that the student has passed class 7th as well. That means if a function is continuous, then definitely limit does exist, right? Limit is the first level. Continuity is the second level, next level. So if the function is continuous, obviously it has passed the limit test, right? Clear? Okay. Alright. If I tell you if the function is continuous, what about differentiability? So differentiability may or may not exist. We need to check for the differentiability. Simply, if you are seeing grade 8th mark sheet, you cannot comment about class 9th mark sheet. You will have to check whether that person has passed differentiability or not. But if a function is differentiable, if a function is sure differentiable, that means if a person has passed class 9th, that means you are damn sure that that function is continuous and limit exists, because differentiability is the last stage. If a function is differentiable, definitely it has passed the continuity test and limits test as well. Yes? Getting my point? Getting my point? Okay. Okay, let me ask you one more question. If I find that a function is discontinuous, can you comment on differentiability? If a function is discontinuous, you know that the function is discontinuous. Can you comment on differentiability? Can you comment on differentiability? Obviously, if a person has failed class 8th, obviously it has failed class 9th, we can say. So, if it is discontinuous, it is definitely non-differentiable. And if a function is non-differentiable, if a function is non-differentiable, can you comment on continuity? Can you comment on continuity? If a function is non-differentiable. So, if a function is non-differentiable, that means a student has not passed his class 9th. So, will it be mandatory? Will it be sure that he has failed class 8th too? Yes, it may or may not be continuous. You cannot comment on continuity, because if a person is showing you that, ma'am, I have failed class 9th, I cannot blindly say, okay, you must have failed class 8th also. Maybe he is passed class 8th, or maybe, you never know. Okay, getting my point? Okay, so this is, if a function, final, you can write it down. If a function is differentiable, then you are sure that it has passed continuity level, because this is the level L, then C, then D. If it is differentiable, then limits and continuity जो है वो करके आया है. Okay, this is the example. If a function is differentiable, obviously the function was continuous because there were no jumps, no break. But if a function is continuous, then differentiability we need to check. This is the example. Let's see. This function is continuous. Can you see that? The function is continuous, but it has a sharp corner, and because of the sharp corner, this function is non-differentiable. So this is continuous but non-differentiable. So continuity never ever guarantee differentiability. Continuity never guarantee differentiability. Are you getting my point? Yes. Now, if a function is discontinuous, I have already told you, if a function is discontinuous, that simply means if it has failed continuity test, then we can't promote it to differentiability, and we cannot promote it to next level. If continuity has failed, then what about differentiability? We can't let it go towards differentiability. So if a function is discontinuous, that means it has jumps, it has breaks, and the function cannot be differentiable. And if a function is non-differentiable, as you can see, non-differentiable, that means sharp corner, doesn't mean it is discontinuous because this function is discontinuous. Can you see? This is non-differentiable because of the sharp corner, but this function is continuous. So non-differentiability does not guarantee discontinuity. This is continuous. This is because of sharp corner, this is non-differentiable. Okay, so this is a continuous function, but so it has passed class 8th, but it has failed class 9th. It can happen. Okay, so finally this is the conclusion. Right? This is the conclusion. Now one more thing. The moment you see the question of differentiability, the question for differentiability, don't just try to go for differentiability. See it this way. Okay, if the question is asking you to check for differentiability, try checking continuity first, because what happens in many cases is the function is not at all continuous. And if the function is not at all continuous, if I tell you there is a function which is not continuous, so what you will say? Will you check for differentiability? Are you this dumb? No, you will say if the function has failed continuity, why will I check differentiability? Why will I go to the next level? So whenever you see the problem for differentiability, always check continuity first. Are you getting my point? Yes or no? Okay. Now let's check the differentiability of function with the ninja technique which I told you. Quickly, 2-second problem with the help of shortcut method. Just derivate it, differentiate it. Okay, alright. So LHD, for LHD, you need to go towards the left hand side of 0, this, so differentiate this, e raised to power 2x, to put x equal to 0, so you will get e raised to power 0 into 2, so you will get 2. What about RHD? For RHD, you will differentiate this, 2 cos x, put x equal to 0, so this will become 2, so 2 differentiable. No need to do this LHD, RHD, the bigger one. Why? For JEE Mains, this is the best method. What about this? Acha, by the way, please check the continuity first. The moment you check, no. Is this function continuous? Put x equal to 0 over here. Is this function even continuous? X equal to 0. E raised to power 0 is 1. Right? So left hand limit, what is left hand limit? 1. What is right hand limit at x equal to 0? So 2 into 0 is equals to. So this function limit does not exist. Limit does not exist. Are you getting my point? Are you getting my point? Don't make this mistake. It may happen that differentiability can match. It can happen that differentiability can match. LHD is equal to RHD, function is differentiable. No, it doesn't work like that, because you can clearly see this function limit LHL is not equal to RHL. That means you are saying, okay ma'am, limit does not exist, continuous, discontinuous, but differentiably yes. Not possible. Yeah, it is live. Got it? Got my point? Did you get my point? Yes? Okay, next question. So what will you do? The moment you need to check the differentiability, do not check the differentiability. Check the continuity. Okay, alright. Okay. So check the continuity. Let's check the continuity. So f of 1 minus. 1 minus means less than 1. Put it here. 1 plus 2x. So this will become what? 1 minus is 1. So 2 multiply 1.9999. So it will become what? Very close to, just less than 2. So 1 plus 1. So this is it. Okay. What about f of 1? F of 1. So f of 1 would be, this would be 0 and then this would be 1. Again, the function is discontinuous. Do I need to check? Do I need to check for the differentiability? Not at all. Getting my point? Getting my point? So whenever you need to check the differentiability, okay. Whenever, okay, 0.9 is so sorry, 0.99. So ये 1 ही हो जाएगा. हाँ 1 ही होगा ना. Hmm, 0.99 correct है ना? 9 2s are 18. 1.8 का GIF 1 correct. हाँ sorry, blah blue blue, it was a mistake. 2.2 multiply 0.9999. 1 ही आएगा ये है ना? It was a mistake. So sorry about that. But anyway, the function is discontinuous. Do I need to check the differentiability? No. So whenever in the JEE Main 2024, you need to check the differentiability, you will check the continuity first, then later on, if it is continuous in case, then you will be able to check the differentiability. Okay, perfect. Now differentiability at a point. So what we were doing till now, you have already seen, we were only checking differentiability at a point, just like the continuity we have studied. So differentiability in an interval. So what will you do? For example, if you are talking about you need to check differentiability in an interval in x belongs to a comma b. So again, 3 things you need to check. 3 things. The function should be differentiable in the interval. It should be differentiable in the interval, right? First thing, differentiable at every point, just like this. The function should be continuous and differentiable in the interval. The second point is end points. The second point is f dash a plus should be equal to the right hand derivative, which is f of a plus h minus f of a upon h. Okay. So in here, what we will do is at the point A, we will only consider right hand derivative because we cannot go towards the left. Okay. And what about B? For B, we will only check f dash b minus. So this should be finite and exist. This limit should be finite and exist. That's it. This limit should be finite. Okay. Only calculate the limit h tend to 0 plus, and this limit should be finite, and obviously it will exist. This is one-sided limit. What about this? So this is f of a minus h minus f of a upon minus h, limit h tend to 0 minus. This also should exist, but this is what for B, okay. So left hand derivative of B should exist. LHD for B should exist. सिर्फ exist बोल रही हूँ मैं. I am talking about सिर्फ existing, only existing. And right hand RHD for A should exist. That's it. And in between, the function should be differentiable in an interval. Again, the same question which happened in continuity. That okay, ma'am, what you are saying, the very first point you said that the function, you need to check at each and every point between A and B, and there are crores and crores, infinite points between A and B. How do we check at each and every point of A and B? Yes, 2025 mains you can attend. Okay, so the question arises that how can I, ma'am, I am one person, how can I check differentiability for infinite points? Again, so doubtful points for differentiability, just like we have studied doubtful points for continuity, okay, right? So all the points of continuity are same. First is boundary points, okay. Second is where the definition changes, okay. And I already told you this, GIF f of x, comma fractional part of f of x. In both the cases, whenever fx is an integer, you will have to check, yes, suspicious points, and signum of f of x, if it happens, so fx is equals to 0 would be your doubtful point. So this is all the points of continuity plus, let me change the color of my pen, plus one last extra point added for the differentiability, because these are the point of continuity only. Because if the continuity fails, differentiability will anyway fail. Plus one more point, you need to check, in case of mod of fx, you need to check for fx is equal to 0. And this is the point of sharp corner. This is the only point in which the function will be continuous but not differentiable. Because sharp corner means continuity but not differentiability. Are you getting my point? Only this particular thing added, rest everything same as continuity, the way you were checking the continuity. Yes? Perfect. Let's talk about the differentiability of mod of x minus 1, right? So if I talk about mod of x minus 1, there are no boundary points, right? No boundary points, no definition change by the way, okay? No greatest integer function, no fractional part function, no signum function, only this mod fx. Sharp corner can happen over here. So first method 1 is try to plot the graph, figure out. Method 1 is actually, yes, fx is equals to 0. Whatever which is inside fx equated to 0. So x minus 1 equal to 0, x equal to 1. This is your doubtful point. Check on this point. Done. Okay. This is your method number 1. Right? Calculate LHD and RHD. This is your method number 1. Method number 2. Plot the graph. So you all know this. This is the graph. This is the sharp corner. X equal to 1. Non-differentiable. Method number 2. Right? Method number 3. Method number 3. What is method number 3? You can actually define it. Fx is equals to mod x minus 1. Definition of mod x minus 1 you know. X minus 1 and 1 minus x. When x is greater than or equal to 1. When x is less than 1. Now differentiate it. RHD. Differentiate it. 1. LHD. Differentiate it. Ninja technique. Minus 1. Both are not equal, non-differentiable. Yes, 3 methods. 3 methods, 1 question. By the way, which is your favorite method? Which is your favorite method? Now these two are homework questions for you. Note it down, take screenshot quickly. This we have already done actually. This we have already done. This was like, x minus 1, x minus 2. So 1 and 2, right? This graph will look like this. Comment on differentiability. Non-differentiable at 2 points. What about? So this is your log x. What about mod log x? Mod log x will look like this. At x equal to 1, you will get a sharp corner. So 2 points of non-differentiability, 1 point of non-differentiability. 2 points of non-differentiability. Simply you have to just equate it to 0. X square minus 3x plus 2 is equals to 0. X is equals to 1 and 2. ये 1 and 2 पे non-differentiability. What about this? Log x कब 0 होता है? When log x is 0, when x is equals to 1. X equals to 1. Got it? Got it? Okay. Now again, master table from master teacher. Master table from master teacher. If your fx and dx both are differentiable, then differentiable, just that gx cannot be equal to 0. When this is differentiable and this is non-differentiable, then definitely this is non-differentiable. Then definitely sum and difference is non-differentiable. Baki I cannot say, may not be. May or may not be. Same table copy paste. Continuity ka table copy paste. May not be. है ना? If both are non-differentiable, non, why cannot say may not be, may not be, may not be. May not. Nigamanth is saying I am quite very late, I guess. Sorry, ma'am. Actually, you are 5.5 hours late, to be precise. All right. Coming towards the last part of the segment, last like 5 minutes, I'll be wrapping up this session now. Okay. So these questions are very much trending in your JEE Main 2023, 2022, 2021, and trust me, it will continue to trend in 2024 as well. Okay. So what are these kind of functions? Just what you need to do, again, graphical thing. So here you need to plot the graph of such functions which have either minimum or maximum. So maximum of 2 functions. Okay. So here what we need to do is we need to plot the minimum of sin x and cos x. How do we do that? Very simple. Just plot the graph of sin x and cos x in the same graph. Okay. So let me just plot this. Okay. Minus pi to pi. So minus pi is this, 0, minus pi to pi this, and this. This is your sin x, right? Okay. What about cos x? So cos x look like this. This is your cos x, right? Okay. Now listen to me carefully. What you need to do is, let me take another color, green color. Okay. So I need to shade the minimum of both the curves, right? Now tell me, at minus pi exactly, which point, which graph is lower, which graph is below, which graph is downwards? नीचे को इंग्लिश में क्या बोलते हैं यार? Tell me, which graph? Okay, so I can see the red line is below. Okay, so try shading minimum. Now I can clearly see that red and yellow are meeting, and post this point, yellow is going down and red is going above, right? So now from this point I need to shade the minimum. So minimum means lower. Minimum. Oh, there is a wrap. You know the wrap. Minimum. You know the wrap. Minimum. Now this is the point where red and yellow are crossing, and this is the point where red is slightly below the yellow. So we need minimum below. Minimum. Getting my point? So what is the shaded area? Let me just erase the non-shaded area. So this will go. Okay. Undo नहीं होता है. Okay. Yes. Okay, so let me just mark it as blue. Only blue color area will be the final graph. Rest all we can delete. Only the blue shading will be our area. Now you just tell me, what are the sharp corners? Can you see the sharp corner? I can see one sharp corner. This is the graph, right? I can see another sharp corner. Only two sharp corners. Only two sharp corners. Only two sharp corners. Can you see? Only two sharp corners. Where? Minus pi by, okay. Where minus 3 pi by 4 is the point and pi by 4 is the point. Minus 3 pi by 4 and pi by 4 is the point. So this is it. If I talk about the differentiability, yes Bhanu Pratap? If I talk about differentiability, minus 3 pi by 4 and pi by 4 are the 2 points where this fx is non-differentiable. Yes, non-differentiable. JEE Main 2019. Can you see the question? Again, same question. fx is minimum of sin x comma cos x. Interval is same, minus pi to pi. And we need to figure out set of points where the function is non-differentiable. Okay, all right. So we know this fx is non-differentiable at minus 3 pi by 4 and pi by 4. But the question is asking something else. We have already done this question actually without knowing. So then S is a subset of which of following? So these two are subset of which of the following set? So the set which is having minus 3 pi by 4 and pi by 4 both will be my answer. Let me check. Option A is having minus 3 pi by 4 and pi by 4. So option A is my answer. Option B is not having pi by 4. So B is rejected. Option C is not having minus 3 pi by 4, rejected. Option D is also rejected. Only option A. Yes, same question. Last question. Last question. Shall I give it homework or shall I do it? This is the last question. Up to you. Do you want to do it with me? Last question. See, I told you maximum minimum question aate hain. It is there in 2021. Go check out. Check out previous year question. These type of questions are there in 2021, 2022, 2023, 2024. Okay, let's do it now. Okay. So what does this question says? It says that we have an fx and there are two branches. The first is x less than mod x less than or equal to 2. Okay. So mod x less than or equal to 2 this branch, and when mod x is between 2 to 4 this branch. ठीक है? Alright. Let S be the set of points in the interval at which f is not differentiable, then at S is. So basically we need to figure out points of differentiability. For that we need to plot this graph. So सबसे पहले maximum of this. So maximum of mod x comma x square. Alright. So let's just plot mod x. And we need to plot this. So this is your 1, this is your 2, this is your minus 1, this is your minus 2. Okay. How will mod x look like? It will look like this. This is your mod x. Perfect. Okay. And you need to plot with the mod x, you need to plot x square. So like I told you, maximum of mod x comma x square. So you need to plot both the curves in one single graph. Plot x square. So if I plot x square, y is equals to x square, how will it look like? If you put 0, you will get 0. If you put 1, you will get 1. If you put minus 1, again you will get 1. So it will cross this function at this point, and at point 2 actually what is happening, you are getting a 2, but at 2 you will get a 4 in this particular graph. Okay, you will get a 4 and you will, yes. So the graph will look like this. So at 2 you will get a 4 finally. Okay. Let me just draw it one more time. So 1, 2, 3, 4. So let me just draw x square first. And this is your 1. Then let me just draw mod x now. We need to draw maximum this time. We need to draw maximum of these two functions this time. Maximum, that means the graph which is above, relatively above. Okay. So this is your 1 and this is your 2. At 2 you will get a value 2, but at 2 you will get a value 4, right? So this will be the graph, this will be the shading as you can see, and this will be the shading, this will be the shading, you can see. Okay, 1 minus 1, right? You can see that red one is above the yellow one in this particular portion, but post one what is happening? Post one what is happening? Yellow one is above. So I am going to plot maximum, the upper graph. Okay, so I can clearly see 1 and minus 1 are having sharp corner along with 0. I can clearly see 1, minus 1 and 0 are having sharp corner, correct? This is not of my use. This we can clearly delete. This red thing is not of my use. Okay. Now what about 2 to 4? What is happening in 2 to 4? What is happening in 2 to 4? So if I talk about the positive side, 8 minus 2x, when x is starting from 2 to 4, right? The moment I plug in 2 over here, so I will get 8 minus 4, I get 4. I get a 4 actually. So what is happening? So my straight line will look like this. And the moment I plug in 4 in 8 minus 2x, the moment I plug in 4, I will get a 0. So the line will look like this, and this line will also look like this. So this is the graph. So at minus 2 and at plus 2, you can clearly see there is a sharp corner. Can you see at minus 2 and plus 2? So how many points? 0, plus minus 1, plus minus 2. Total 5 points are there at which my curve is non-differentiable. Option A is absolutely right. Okay. Yes, 0 also. Yes, 0 also. I know that this is the last question, and I know that you guys, maybe some of you might have not understood this problem nicely. So what I will tell you is, after this class, not today maybe because it has been like almost 6 hours, maybe tomorrow. Tomorrow the first thing which you are going to do, what you are going to do is, whatever you have not understood now, whatever you have not understood, just try those, only those questions tomorrow, the very first thing, and post that you know what to do, right? Now how to exit this? Keep. How to exit this? From current slide, yes. Yeah. So few things, VDPP, Vedantu daily practice problem, you have to attend, you have to go, okay. This is the thing, and there is one important update that you have to join our Telegram channel, and the Telegram channel link is already given in the description box, okay. All right, the link is given in the description box, that you have to do. Along with that, okay, how to exit? How to exit? How to exit? Okay, all right, okay. Just trying to open the YouTube. How to open a YouTube? Okay, anyway, you must be actually having the YouTube access, right? So if you go to the YouTube, go on the YouTube channel Vedantu JEE, which you are already live on. So what you have to do is, we have a PYQ session tomorrow. You all know that tomorrow 11 o'clock Shreyas sir will be taking PYQ session. Post that Namrata Ma'am will be taking, and then I'll be taking LCD PYQs. So do attend that session, only thing I wanted to tell you, and do join Telegram channel Vedantu JEE English, okay. Alright, so now I will take your leave. It's been so long, you guys have to sleep as well. Sleep well. Do wake up early so that you can join the session, 11 o'clock session on the time. This is me, Namrata, signing off. I'll see you all tomorrow.